Hey everyone, welcome to Simplilearn's YouTube channel. Today, we will be discussing the cloud computing interview questions. But before that, let me share a few facts with you. According to O'Reilly, more than 90% of the organizations are expected to increase their cloud infrastructure. In 2021, the upshot is that the majority of cloud users plan to scale their business in the cloud rather than reducing their cloud usage share. Suppose you are very much interested in cloud industry, then you have come to the right place. Welcome to this video on cloud computing interview questions. In this video, we will learn everything about AWS and Azure in detail. Our interview questions are divided into 3 segments: beginner level, intermediate level, and advanced level. By the end of this video, I can assure you that all your AWS and Azure related queries would have been answered. For this training with me, I have our experienced AWS and Azure expert, Sam, who will take you through the various topics of Azure. So, let's get started with an exciting video on cloud computing interview questions. Before we begin, please make sure to get subscribed to our YouTube channel and hit that bell icon to never miss an update from Simplilearn.
Hi there, I'm Samuel, and I'm here to walk you through some of the AWS interview questions which we find are important. And our hope is that you would use this material in your interview preparation and be able to crack that cloud interview and step into your dream cloud job. By the way, I'm a cloud technical architect, trainer, and an interview panelist for cloud, network, and DevOps. So as you progress in watching, you're going to see that these questions are practical scenario-based questions that tests the depth of the knowledge of a person in a particular AWS product or in a particular AWS architecture. So why wait? Let's move on. All right, so in an interview, you would find yourself with a question that might ask you, define and explain the 3 basic types of cloud services and the AWS products that are built based on them. See, here, it's a very straightforward question. Just explain 3 basic types of cloud service. And when we talk about basic type of cloud service, it's compute, obviously, that's a very basic service. Storage, obviously, because you need to store your data somewhere. And networking, that actually connects a couple of other services to your application. These basic will not include monitoring. These basic will not include analytics because they are considered as optional. They are considered as advanced services. You could choose a non-cloud service or a product for monitoring and for analytics. So they're not considered as basic. So when we talk about basics, they are compute, storage, and networking. And the second part of the question says, explain some of the AWS products that are built based on them. Of course, compute, EC2 is a major one. That's the major share of the compute resource. And then we have platform as a service, which is Elastic Beanstalk. And then function as a service, which is Lambda. Autoscaling and Lightsail are also part of compute services. So the compute domain, it really helps us to run any application, and the compute service helps us in managing the scaling and deployment of an application. Again, Lambda is a compute service, so the compute service also helps in running event initiated stateless applications. The next one was storage. A lot of emphasis is on storage these days because if there's one thing that grows in a network on a daily basis, that's storage. Every new day we have new data to store, process, manage. So storage is again a basic and an important cloud service. And the products that are built based on the storage services are S3, object storage, Glacier for archiving, EBS, Elastic Block Storage as a drive attachment for the EC2 instances, and EFS, file share for the EC2 instances. So the storage domain helps in the following aspects. It holds all the information that the application uses, so it's the application data. And we can also archive old data using storage, which would be Glacier, and any object files and any requirement for block storage can be met through Elastic Block Store and S3, which is again an object storage. Talking about networks, It's just not important to answer the question with the name of the services and the name of the product. It'll also be good if you could go in depth and explain how they can be used. Right, so that actually proves you to be a person knowledgeable enough in that particular service or product. So, talking about networking domain, VPC, networking, can't imagine networking without VPC in a cloud environment, especially in AWS cloud environment. And then we have Route 53 for domain resolution or for DNS. And then we have Cloudfront, which is an edge caching service that helps customers to read their application with low latency. So, networking domain helps with some of the following use cases. It controls and manages the connectivity of the AWS services within our account. And we can also pick an IP address range. If you're a network engineer or if you are somebody who works in networks or are planning to work in network, you will soon realize the importance of choosing your own IP address for easy remembering. So having an option to have your own IP address in the cloud, own range of IP address in the cloud, it really helps, really helps in cloud networking. The other question that get asked would be the difference between the availability zone and the region. Actually, the question generally gets asked so to test how well you can actually differentiate and also correlate the availability zone and the region relationship. Right? So a region is a separate geographic area like the US West 1, which represents North California, or the AP South, which represents Mumbai. So regions are a separate geographic area. On the contrary, availability zone resides inside the region. You shouldn't stop there. You should go further and explain about availability zones. And availability zones are isolated from each other, and some of the services will replicate themselves within the availability zone. So availability zone does replication within them, but regions, they don't generally do replication between them. The other question you could be asked is, what is autoscaling? What do we achieve by autoscaling? So in short, autoscaling, it helps us to automatically provision and launch new instances whenever there is an demand. It not only helps us meeting the increasing demand, it also helps in reducing the resource usage when there is low demand. So autoscaling also allows us to decrease the resources or resource capacity as per the need of that particular hour. Now, this helps business in not worrying about putting more effort in managing or continuously monitoring the server to see if they have the needed resource or not, because autoscaling is going to handle it for us. So business does not need to worry about it. And autoscaling is one big reason why people would want to go and pick a cloud service, especially an AWS service. The ability to increase and shrink based on the need of that hour. That's how powerful is autoscaling. The other question you could get asked is, what's geo-targeting in Cloudfront? Now we know that Cloudfront is caching, and it caches content globally in the Amazon caching service global wide. The whole point is to provide users worldwide access to the data from a very nearest server possible. That's the whole point in using or going for Cloudfront. Then what do you mean by geo-targeting? Geo-targeting is showing customer and specific content. Based on language, we can customize the content. Based on what's popular in that place, we can actually customize the content. The URL is the same, but we could actually change the content a little bit. Not the whole content, otherwise it would be dynamic, but we can change the content a little bit, a specific file or a picture or a particular link in a website, and show customized content to users who will be in different parts of the globe. So how does it happen? Cloudfront will detect the country where the viewers are located, and it will forward the country code to the origin server. And once the origin server gets the specialized or a specific country code, it will change the content and it will send to the caching server, and it gets cached there forever. And the user gets to view a content which is personalized for them for the country they are in. The other question you could get asked is the steps involved in using CloudFormation or creating a CloudFormation or backing up an environment with a CloudFormation template. We all know that if there is a template, we can simply run it and it provisions the environment, but there is a lot more going into it. So the first step in moving towards infrastructure as a code is to create the CloudFormation template, which as of now supports JSON and YAML file format. So first create the CloudFormation template and then save the code in an S3 bucket. S3 bucket serves as the repository for our code, and then from the CloudFormation call the file in the S3 bucket and create a stack. And now CloudFormation uses the file, reads the file, understands services that are being called, understands the order, understands how they are connected with each other. CloudFormation is actually an intelligent service. It understands the relation. Based on the code, it would understand the relationship between the different services, and it would set an order for itself and then would provision the services one after the other. Let's say a service has a dependency, and the dependent service, the other service which this service, let's say service A and B, service B is dependent on service A, let's say. CloudFormation is an intelligent service. It would provision the resource A first and then would provision resource B. What happens if we inverse the order? If we inverse the order, resource B first gets provision, and because it does not have dependency, chances that the CloudFormation's default behavior is that if something is not provisioned properly, if something is not healthy, it would roll back. Chances that the environment provisioning will roll back. So to avoid that, CloudFormation first provisions all the services that has or that's dependent by another service. So it provisions those services first and then provisions the services that has dependencies. And if you're being hired for a DevOps or if the interviewer wanted to test your skill on systems side, this definitely would be a question in his list. How do you upgrade or downgrade a system with near zero downtime? Now everybody's moving towards zero downtime or near zero downtime. All of them want their application to be highly available. So the question would be, how do you actually upgrade or downgrade a system with near zero downtime? Now we all know that I can upgrade an EC2 instance to a better EC2 instance by changing the instance type, stopping and starting. But stopping and starting is going to cause a downtime, right? So you should be answering, or you should be thinking in those terms, because that's a wrong answer. Specifically, the interviewer wants to know, how do you upgrade a system with zero downtime? So upgrading system with zero downtime, it includes launching another system parallelly with the bigger EC2 instance type with a bigger capacity and install all that's needed. If you're going to use an AMI of the old machine, well and good. You don't have to go through installing all the updates and installing all the application. From the AMI, once you've launched it in a bigger instance, locally test the application to see if it is working. Don't put it on production yet. Test the application to see if it is working. And if the application works, we can actually swap. If your server is behind Route 53, let's say, all that you could do is go to Route 53, update the information with the new IP address of the new server, and that's going to send traffic to the new server now. So the cutover is handled. Or if you're using static IP, you can actually remove the static IP from the old machine and assign it to the new machine. That's one way of doing it. Or if you are using elastic NIC card, you can actually remove the NIC card from the old machine and attach the NIC card to the new machine. So that way we would get near zero downtime. If you're hired for an architect level, you should be worrying about cost as well, along with the technology. And this question would test how well you manage cost. So what are the tools and techniques we can use in AWS to identify and know that we are paying the correct amount for the resources that we are using? Or how do you get a visibility of your AWS resources running? One way is to check the billing. There's a place where you can check the top services that were utilized. It could be free and it could be paid service as well. Top services that can be utilized. It's actually in the dashboard of the cost management console. So that table here shows the top 5 most used services. So looking at it, you can get it. All right, so I'm using a lot of storage. I'm using a lot of EC2. Why is storage high? You can go ahead and try to justify that, and you will find if you are storing things that shouldn't be storing, and then clean it up. Why is compute capacity so high? Why is data transfer so high? So if you start thinking in those levels, you'll be able to dig in and clean up unnecessary and be able to save your bill. And there are cost explorer services available which will help you to view your usage pattern or view your spending for the past 13 months or so, and it will also forecast for the next 3 months. Now, how much will you be using if your pattern is like this? So that will actually help and will give you a visibility on how much you have spent, how much you will be spending if the trend continues. Budgets are another excellent way to control cost. You can actually set a budget. All right, this is how much I am willing to spend for this application, for this team, or for this month, for this particular resource. So you can actually put a budget mark, and anytime it exceeds, anytime it's nearing, you would get an alarm saying that, well, we're about to reach the allocated budget amount. Stuff like that. That way you can go back and know, and you know that how much the bill is going to be for that month, or you can take steps to control bill amount for that particular month. So AWS budget is another very good tool that you could use. Cost allocation tags helps in identifying which team or which resource has spent more in that particular month. Instead of looking at the bill as one list with no specifications into it, and looking at it as an expenditure list, you can actually break it down and tag the expenditure to the teams with cost allocation tags. The dev team has spent so much. The production team has spent so much. The training team has spent more than the dev and the production team. Why is that? Now, you'll be able to think in those levels only if you have cost allocation tags. Now, cost allocation tags are nothing but the tags that you would put when you create a resource. So for production services, you would put as a production tag, you would create a production tag and you would associate that resources to it. And at a later point, when you actually pull up your bill, that's going to show a detailed list of this is the owner, this is the group, and this is how much they have used in the last month. And you can move forward with your investigation and encourage or stop users using more services with the cost allocation tags. The other famous question is, are there any other tools or is there any other way of accessing AWS resource other than the console? Console is GUI, right? So in other words, other than GUI, how would you use the AWS resource and how familiar are you with those tools and technologies? The other tools that are available that we can leverage and access the AWS resource are, of course, PuTTY. You can configure PuTTY to access the AWS resources, like log into an EC2 instance. An EC2 instance does not always have to be logged in through the console. You could use PuTTY to log into an EC2 instance, and like the jump box, like the proxy machine, and like the gateway machine. And from there, you can actually access the rest of the resources. So this is an alternative to the console. And of course, we have the AWS CLI in any of the Linux machines or Windows machines. We can install, so that's point 2, 3, and 4. We can install AWS CLI for Linux, Windows, also for Mac. So we can install them, and from there, from your local machine, we can access, run AWS commands and access, provision, monitor the AWS resources. The other ones are, we can access the AWS resource programmatically using AWS SDK and Eclipse. So these are a bunch of options we have to use the AWS resource other than the console. If you're interviewed in a company or by a company that focuses more on security and want to use AWS native services for their security, then you would come across this question. What services can be used to create a centralized logging solution? The basic services we could use are CloudWatch logs, store them in S3, and then use Elasticsearch to visualize them, and use Kinesis to move the data from S3 to Elasticsearch. Right? So log management, it actually helps organizations to track the relationship between operational and security changes and the events that got triggered based on those logs. Instead of logging into an instance or instead of logging into the environment and checking the resources physically, I can come to a fair conclusion by just looking at the logs. Every time there's a change, the system would scream and it gets tracked in the CloudWatch, and then CloudWatch pushes it to S3. Kinesis pushes the data from S3 to Elasticsearch, and I can do a time-based filter and I would get a fair understanding of what was going on in the environment for the past 1 hour or whatever the time window that I wanted to look at. So it helps in getting a good understanding of the infrastructure as a whole. All the logs are getting saved in one place, so all the infrastructure logs are getting saved in one place, so it's easy for me to look at it in an infrastructure perspective. So we know the services that can be used, and here are some of the services and how they actually connect to each other. It could be logs that belongs to one account. It could be logs that belongs to multiple accounts. It doesn't matter. Those three services are going to work fairly good, and they're going to inject or they're going to suck logs from the other accounts, put it in one place and help us to monitor. So as you see, you have CloudWatch here that actually tracks the metrics. You can also use CloudTrail if you want to log API calls as well, push them in an S3 bucket. So there are different types of log. Flow logs are getting captured in an instance. Application logs are getting captured from the same VPC, from a different VPC, from the same account, from a different account. And all of them are analyzed using Elasticsearch using the Kibana client. So step 1 is to deploy the ECS cluster. Step 2 is to restrict access to the ECS cluster because it's valid data. You don't want anybody to put their hands and access their data. So restrict access to the ECS dashboard. And we could use Lambda also to push the data from CloudWatch to the Elasticsearch domain. And then Kibana is actually the graphical tool that helps us to visualize the logs instead of looking at log as just statements or in a bunch of characters, a bunch of files. Kibana helps us to analyze the logs in a graphical or a chart or a bar diagram format. Again, in an interview, the interviewer is more concerned about testing your knowledge on AWS security products, especially on the logging, monitoring, event management, or incident management. Then you could have a question like this: what are the native AWS security logging capabilities? Now, most of the services have their own logging in them, like S3. S3 has its own login, and CloudFront has its own logging. DS has its own logging. VPC has its own logging. In addition, there are account level logins like CloudTrail and AWS config services. So there are a variety of logging options available in the AWS, like CloudTrail, config, CloudFront, Redshift logging, RDS logging, VPC flow logs, S3 object logging, S3 access logging, stuff like that. So we're going to look at two servers in specific. CloudTrail. Now this CloudTrail, the very first product in that picture we just saw, the CloudTrail provides an very high level history of the API calls for all the accounts. And with that, we can actually perform a very good security analysis of our account. And these logs are actually delivered to, you can configure it, they can be delivered to S3 for long time archivals. And based on a particular event, it can also send an email notification to us saying, hey, just got this error, thought I'll let you know, stuff like that. The other one is config service. Now, config service helps us to understand the configuration changes that happened in our environment, and we can also set up notifications based on the configuration changes. So it records the cumulative changes that are made in a short period of time. So if you want to go through the lifetime of a particular resource, what are the things that happened? What are the things it went through? They can be looked at using AWS config.
All right. The other question you could get asked is if your role includes taking care of cloud security as well. Then the other question you could get asked is the native services that Amazon provides to mitigate DDoS. which is denial of service. Now, not all companies would go with Amazon native services, but there are some companies which want to stick with Amazon native services just to save them from the headache of managing the other softwares or bringing in another tool, a third-party tool, into managing DDoS. They simply want to stick with Amazon proprietary Amazon native services, and a lot of companies are using Amazon service to prevent DDoS, denial of service. Now, denial of service is, if you already know what denial of service is, well and good. If you do not know, then let's know it now. Denial of service is a user trying to or maliciously making attempt to access a website or an application. The user would actually create multiple sessions and he would occupy all the sessions, and he would not let legitimate users access the service. So he's in turn denying the service for the user. A quick picture review of what denial of service is. Now look at it. These users, instead of making one connection, they are making multiple connections, and there are cheap software programs available that would actually trigger connections from different computers in the internet with different MAC addresses, so everything kind of looks legitimate for the server, and it would accept those connections and it would keep the sessions open. The actual users won't be able to use them, so that's denying the service for the actual users, denial of service. All right, and distributed denial of service is generating attacks from multiple places, from a distributed environment. So that's distributed denial of service. So the tools, the native tools that helps us to prevent the denial of service attacks in AWS is Cloud Shield and Web Access Firewall, AWS WAF. Now they are the major ones. They are designed to mitigate a denial of service. If your website is often bothered by denial of service, then we should be using AWS Shield or AWS WAF. And there are a couple of other tools that also does. When I say that also does, denial of service is not their primary job, but you could use them for denial of service. Route 53's purpose is to provide DNS. Cloudfront is to provide caching. Elastic Load Balancer, ELB's work is to provide load balancing. VPC is to create an secure virtual private environment. But they also support mitigating denial of service, but not to the extent you would get in AWS Shield and AWS WAF. So AWS Shield and WAF are the primary ones, but the rest can also be used to mitigate distributed denial of service. The other tricky question is this actually will test your familiarity with the region and the services available in the region. So when you're trying to provision a service in a particular region, you're not seeing the service in that region. How do we go about fixing it, or how do we go about using the service in the cloud? It's a tricky question. And if you have not gone through such situation, you can totally blow it away. You really need to have a good understanding on regions, the services available in those regions, and what if a particular service is not available, how to go about doing it. The answer is not all services are available in all regions. Anytime Amazon announces a new service, they don't immediately publish them on all regions. They start small, and as and when the traffic increases, as and when it becomes more likable to the customers, they actually move the service to different regions. So as you see in this picture, within America, North Virginia has more services compared to Ohio or compared to North California. So within North America itself, North Virginia is the preferred one. So similarly, there are preferred regions within Europe, Middle East, and Africa, and preferred regions within Asia Pacific. So anytime you don't see a service in a particular region, chances that the service is not available in that region yet, we got to check the documentation and find the nearest region that offers that service and start using the service from that region. Now you might think, well, if I'm looking for a service in Asia, let's say in Mumbai, and if it is not available, why not simply switch to North Virginia and start using it? You could, but that's going to add more latency to your application. So that's why we need to check for application, which is check for region, which is very near to the place where you want to serve your customers, and find nearest region instead of always going back to North Virginia and deploying your application in North Virginia. Again, there's a link in aws.com that you can go and look for services available in different region, and that's exactly what you're seeing here. And If your service is not available in a particular region, switch to the other region that provides your service, the nearest other region that provides that service, and start using service from there. With the coming up of cloud, a lot of companies have turned down their monitoring team. Instead, they want to go with the monitorings that cloud provides. Nobody wants to, or at least many people don't want to go through the hassle of at least new startups and new companies that are thinking of having a monitoring environment. Now, they don't want to go with traditional NOC monitoring. Instead, they would like to leverage AWS monitorings available because it monitors a lot of stuff, not just the availability, but it monitors a lot of stuff like failures, errors. It also triggers emails, stuff like that. So how do you actually set up a monitor to how do you set up a monitor to monitor the website metrics in real time in AWS? The simple way, anytime you have a question about monitoring, CloudWatch should strike your mind, because CloudWatch is meant for monitoring, is meant for collecting metrics, is meant for providing graphical representation of what's going on in a particular network at a particular point of time. So CloudWatch helps us to monitor applications, and using CloudWatch we can monitor the state changes, not only the state changes, the autoscaling lifecycle events. Anytime there are more services added, there is a reduction in the number of servers because of less usage. Very informative messages can be received through CloudWatch. CloudWatch can now support scheduled events. If you want to schedule anything, CloudWatch has an event that would schedule an action, right? Schedule a trigger, time-based, not incident-based. Anything happening and then you get an action happening that's incident-based. On the other hand, you can simply schedule few things on time-based. So that's possible with CloudWatch. So this CloudWatch integrates very well with a lot of other services like notifications for notifying the user or for notifying the administrator about it. And it can integrate well with Lambda. So to trigger an action, anytime you're designing an auto-healing environment, this CloudWatch can actually monitor and send an email if we are integrating it with SNS, Simple Notification Service. Or this CloudWatch can monitor, and based on what's happening, it can trigger an event in Lambda, and that would in turn run a function till the environment comes back to normal. So CloudWatch integrates well with a lot of other AWS services. Alright, so CloudWatch has 3 statuses: green when everything is going good, yellow when the service is degraded, and red when the service is not available. Green is good, so we don't have to do anything about it. But anytime there's an yellow, the picture that we're looking at, it's actually calling a Lambda function to debug the application and to fix it. And anytime there's a red alert, it immediately notifies the owner of the application about, well, the service is down, and here is the report that I have. Here is the metrics that I've collected about the service, stuff like that. If the job role requires you to manage the servers as well, there are certain job roles which are on the system side. There are certain job roles which is development plus system side. Now you're responsible for the application and the server as well. So if that's the case, you might be tested with some basic questions like the different types of virtualization in AWS and what are the difference between them. Alright, the 3 major types of virtualization are HVM, which is hardware virtual machine. The other one is PV, para virtualization. And the third one is PV on HVM, para-virtualization on hardware virtual module. Alright, the difference between them, or actually describing them, is actually the difference between them. HVM, it's actually a fully virtualized hardware. The whole hardware is virtualized and all virtual machines act separate from each other. And these VMs are booted by executing master boot record in the root block. And when we talk about para-virtualization, Paragrub is actually the special boot loader which boots the PV AMIs. And when we talk about PV on HVM, it's actually the marriage between HVM and PV. And this para-virtualization on HVM, in other words, PV on HVM, it actually helps operating system take advantage in storage and the network input output available through the host. Another good question is, name some of the services that are not region specific. Now, you've been taught that all services are within a region and some services are within an availability zone. For example, EC2 is within an availability zone, EBS is within an availability zone, S3 is region specific, DynamoDB is region specific, stuff like that. VPC is both availability and region specific, meaning subnets are availability zone specific and VPC is region specific, stuff like that. So you might have thought, you might have learned in that combination. But there could be some tricky questions that tests you how well you have understood the region, non-region, and availability, non-availability services. I should say there are services that are not region specific. That would be IAM. So we can't have IAM for every availability zone and for every region, which means users will have to use one username and password for one region, and anytime they switch to another region, they will have to use another username and password. That's more work, and that's not a good design as well. Authentication has to be global. So IAM is a global service, and which means it's not region specific. On the other hand, Route 53 is again a regional specific. So we can't have Route 53 for every region. Route 53 is not a region specific service. It's a global service. And it's one application. Users access from everywhere or from every part of the world. So we can't have one URL or one DNS name for each region if your application is a global application. And then web application firewall works well with CloudFront. Then CloudFront is a region-based service. So the web application firewall, it's not a region-specific service. It's a global service. And CloudFront is again a global service. Though you can cache content on a continent and country basis, it's still considered a global service, right? It's not bound to any region. So when you activate CloudFront, you're activating it away from region or availability zone. So when you're activating a web application firewall, because it's not a region specific service, you're activating it away from availability zone and regions. So a quick recap: IAM users, groups, roles, and accounts, they are global services. They can be used globally. Route 53 services are offered at edge locations and they are global as well. Web application firewall, a service that protects our web application from common web exploits. They are global service as well. CloudFront is Global Content Delivery Network, CDN, and they are offered at edge locations, which are a global service. In other words, non-region specific service or beyond region service. All right, this is another good question as well. In the project that you are being interviewed, if they really want to secure their environment using NAT, or if they are already securing their environment using NAT by any of these two methods like Nat Gateway or Nat instances, you can expect this question. What are the difference between a Nat Gateway and Nat instances? Now, they both serve the same thing, right? So they're not two different services trying to achieve two different things. They both serve the same thing, but still they do have differences in them, right? On a high level, they both achieve providing natting for the service behind it, but the difference comes when we talk about the availability of it. Nat Gateway is a managed service by Amazon, whereas Nat Instance is managed by us. Now I'm talking about the third point, maintenance here. Nat Gateway is managed by Amazon, Nat Instance is managed by us, and availability of Nat Gateway is very high and availability of Nat Instance is less compared to the Nat Gateway because it's managed by us. It's on an EC2 instance which could actually fail, and if it fails we'll have to relaunch it. But if it is Nat Gateway, if something happens to that service, Amazon would take care of reprovisioning it. And talking about bandwidth, it can burst up to 75 gigabits. Now, traffic through the NAT gateway can burst up to 75 gigabits. But for NAT instance, it actually depends on the server that we launch. And if we are launching a T2 micro, it barely gets any bandwidth. So there's a difference there. And the performance, because it's highly available because of the bigger pipe, 75 gigabits, the performance of the NAT gateway is very high, but the performance of the NAT instance is going to be average. Again, it depends on the size of the NAT instance that we pick. And billing. Billing for NAT gateway is the number of gateways that we provision and the duration for which we use the NAT gateway. But billing for NAT instance is number of instance and the type of instance that we use. Of course, number of instance, duration, and the type of instance that we use. Security in Nat Gateway cannot be assigned, meaning it already comes with full packed security. But in Nat instance, security is a bit customizable. I can go and change the security because it's a server managed by me or managed by us. I can always change the security. Well, allow this, don't allow this, stuff like that. Size and load of the Nat Gateway is uniform, but the size and the load of the NAT instance changes as per a NAT gateway is a fixed product, but NAT instance can be small instance, can be a big instance, so the size and the load through it varies. Right. The other question you could get asked is, what are the difference between stopping and terminating an EC2 instance? Now you will be able to answer only if you have worked on environments where you have your instance stopped and where you have your instance terminated. If you have only used lab and are attending the interview, chances are that you always lost when answering this question. It might look like both are the same. Well, stopping and terminating both are the same, but there is a difference in it. So when you stop an instance, it actually performs a normal shutdown on the instance and it simply moves the instance to the stopped state. But when you actually terminate the instance is moved to the stop state. The EBS volumes that are attached to it are deleted and removed, and we'll never be able to recover them again. So that's a big difference between stopping and terminating an instance. If you're thinking of using the instance again along with the data in it, you should only be thinking of stopping the instance, but you should be terminating the instance only if you want to get rid of that instance forever. If you are being interviewed for an architect level position or a junior architect level position or even an cloud consultant level position, or even in an engineering position, this is a very common question that get asked. What are the different types of EC2 instances based on their cost or based on how we pay them, right? They're all compute capacity. For example, the different types are on-demand instances, spot instances, and reserved instances. It kind of looks the same. They all provide the compute capacity. They all provide the same type of hardwares for us, but if you're looking at cost saving or optimizing cost in our environment, we got to be very careful about which one are we picking. Now we might think that, well, I'll go with on-demand instance because I pay on a per hour basis, which is cheap. I can use them anytime I want, and anytime I don't want, I can simply get rid of it by terminating it. You're right, but if the requirement is to use the service for 1 year, the requirement is to use the service for 3 years, then you'll be wasting a lot of money buying on-demand instances. You'll be wasting a lot of money paying on an hourly basis. Instead, we should be going for reserved instance where we can reserve the capacity for the complete 1 year or complete 3 years and save huge amount in buying reserved instances. Alright, so on-demand is cheap to start with if you're only planning to use it for a short while, but if you're planning to run it for a long while, then we should be going for reserved instance. That is what is cost efficient. So spot instance is cheaper than on-demand instance. And there are different use cases for spot instance as well. So let's look at one after the other. The on-demand instance. The on-demand instance is purchased at a fixed rate per hour. This is very short term and irregular workloads. And for testing, for development, on-demand instance is a very good use case. We should be using on-demand for production. Spot instance. Spot instance allows users to purchase EC2 at a reduced price, and anytime we have more instances, we can always go and sell it in spot instances. I'm referring to anytime we have more reserved instances, we can always sell them in spot instance catalog. And the way we buy spot instance is we actually put a budget. This is how much I'm willing to pay. All right, would you be able to give service within this cost? So anytime the price comes down and meets the cost that we have put in, we'll be assigned an instance. And anytime the price shoots up, the instance will be taken away from us. But in case of on-demand instances, we have bought that instance for that particular hour and it stays with us. But with spot instances, it varies based on the price. If you meet the price, you get the instance. If you don't meet the price, it goes away to somebody else. And the spot instance availability is actually based on supply and demand in the market. There's no guarantee that you will get spot instance at all time. All right, so that's a caveat there you should be familiar with. That's a caveat there you should be aware when you are proposing somebody that we can go for spot instance and save money. It's not always going to be available. If you want your spot instance to be available to you, then we need to carefully watch the history of the price of the spot instance. Now, how much was it last month and how much is it this month? So how can I quote, or how much can I quote, stuff like that. So you got to look at those history before you propose somebody that, well, we're going to save money using spot instance. On the other hand, reserved instance provide cost savings for the company. We can opt for reserved instances for 1 year or 3 years. There are actually 3 types of reserved instances: light, medium, and heavy reserved instances. They are based on the amount that we would be paying. And cost benefit also depends with reserved instance. The cost benefit also depends based on, are we doing all upfront or no upfront or partial payment, then split the rest as monthly payments. So there are many purchase options available. But overall, if you're looking at using an application for the next 1 year and 3 years, you should not be going for on-demand instance. You should be going for reserved instance, and that's what gives you the cost benefit. And in an AWS interview, sometimes you might be asked, how you interact with the AWS environment. Are you using CLI? Are you using console? And depending on your answer, whether console or CLI, the panelist put a score. Okay, this person is CLI specific, this person is console specific, or this person has used AWS environment through the SDK, stuff like that. So this question tests whether you are a CLI person or a console person. And the question goes like this: how do you set up SSH agent forwarding so that you do not have to copy the key every time you log in? If you have used PuTTY, anytime if you want to log into an EC2 instance, you will have to put the IP and the port number. Along with that, you will have to map, or we will have to map the key in the PuTTY, and this has to be done every time. That's what we would have done in our lab environments, right? But in production environment, using the same key or mapping the same key again and again every time, it's actually an hassle. It's considered as a blocker. So you might want to cache it. You might want to permanently add it in your PuTTY session so you can immediately log in and start using it. So here, in the place where you would actually map the private key, there's a quick button that actually fixes or that actually binds your SSH to your PuTTY instance. So we can enable SSH agent forwarding that will actually bind our key to the SSH, and next time when we try to log in, we don't have to always go through mapping the key and trying to log in. Alright, this question, what are Solaris and AX operating systems? Are they available with AWS? That question generally gets asked to test how familiar are you with the AMIs available? How familiar are you with EC2? How familiar are you with the EC2 hardwares available? That basically tests that. Now the first question or the first thought that comes to your mind is, well, everything is available with AWS. I've seen Windows, I've seen Ubuntu, I've seen Red Hat, I've seen Amazon AMIs, and if I don't see my operating system there, I can always go to Marketplace and try them. If I don't find a Marketplace, I can always go to Community and try them. So there are a lot of AMIs available, there are a lot of operating systems available. I will be able to find Solaris and AX, but that's not the case. Solaris and AX are not available with AWS. That's because Solaris uses a different Solaris does not support the architecture, does not support public cloud currently. The same goes for AX as well. They run on Power CPU and not on Intel, and as of now, Amazon does not provide Power machines. This should not be confused with HPC, which is high performance computing. Should not be confused with that. Now, these are different hardwares, different CPU itself that the cloud providers they do not provide yet. Another question you could get asked in organizations that would want to automate their infrastructure using Amazon native services would be, how do you actually recover an EC2 instance or auto recover an EC2 instance when it fails? Well, we know that EC2 instances are considered as immutable, meaning irreparable. We don't spend time fixing bugs in an OS, stuff like that. Once an EC2 instance crashes, like it goes on a OS panic, or there are various reasons why it would fail. So we don't have to really worry about fixing it. We can always relaunch that instance and that would fix it. But what if it happens at 2 o'clock in the night? What if it happens during a weekend when nobody's in office looking or monitoring those instances? So you would want to automate that, not only on a weekend or during midnights, but it's general practice good to automate it. So you could face this question: how do you actually automate an EC2 instance once it fails? And the answer to that question is using CloudWatch, we can recover the instance. So as you see, there is an alarm threshold set in CloudWatch. And once the threshold is met, meaning if there is an error, if there is a failure, if the EC2 instance is not responding for a certain while, we can set an alarm. And once the alarm is met, let's say the CPU utilization stayed high for 5 minutes. Right, it's not taking any new connections, or the instance is not pinging for 5 minutes, or in this case it's 2 minutes. It's not pinging, so it's not going to respond connection. So in those cases, you would want to automatically recover that EC2 instance by rebooting the instance. All right, now look at this, the take this action section under the action. So there we have a bunch of options like recover this instance, meaning reboot the instance. So that's how we would recover. The other two options are beyond the scope of the question, but still you can go ahead and apply, just like I'm going to do it. So the other option is stop the instance. That's very useful when you want to stop instances that are having low utilizations. Nobody's using the system as of now. You don't want them to be running and wasting the cloud expenditure. So you can actually set an alarm that stops the EC2 instance that's having low utilization. So somebody was working in an instance and they left it without, or they forgot to shut down that instance, and it gets, they will only use it again the next day morning. So in between there could be like 12 hours that the system is running idle, nobody's using it, and you're paying for it. So you can identify such instances and actually stop them when the CPU utilization is low, meaning nobody is using it. The other one is to terminate. Let's say you want to give system to somebody temporarily and you don't want them to hand the system back to you, right? This is actually an idea. In other words, this is actually the scenario. So you hand over a system to somebody, and when they're done, they're done. We can actually terminate the system. So you could instruct the other person to terminate the system when they're done, and they could forget and the instance could be running forever. Or you can monitor the system after the specified time is over and you can terminate the system. Or best part, you can automate the system termination. So you assign a system to somebody and then turn on this CloudWatch action to terminate the instance when the CPU is low for like 2 hours, meaning they've already left, or CPU is low for 30 minutes, meaning they've already left, stuff like that. So that's possible. And if you're getting hired for an system side architect, or even on the sysops side, you could face this question: what are the common and different types of AMI designs? There are a lot of AMI designs. The question is the common ones and the difference between them. So the common ones are the full back AMIs, and the other one is just enough OS AMI, JEOS AMI, and the other one is hybrid type AMIs. So let's look at the difference between them. The full backed AMI, just like the name says, it's fully baked. It's ready to use AMI. This is the simplest AMI to deploy. Can be a bit expensive, it can be a bit cumbersome because you'll have to do a lot of work beforehand. You could use the AMI, so a lot of planning, a lot of thought process will go into it, and the AMI is ready to use, right? You hand over the AMI to somebody and it's ready to use, or if you want to reuse the AMI, it's already ready for you to use. So that's full baked AMI. The other one is just enough operating system AMI, just like the name says. It has, as you can also see in the diagram, or in the picture, it covers a part of the OS. All bootstraps are already packed properly, and the security monitoring, logging, and the other stuff are configured at the time of deployment or at the time you would be using it. So not much thought process will go in here. The only focus is on choosing the operating system and what goes, the operating system specific agents or bootstraps that goes into the operating system. That's all we worry about. The advantage of this is it's flexible, meaning you can choose to install additional softwares at the time of deploying, but that's going to require an additional expertise on the person who will be using the AMI. So that's another overhead there. But the advantage is that it's kind of flexible. I can change the configurations during the time of deployment. The other one is a hybrid AMI. Now the hybrid AMI actually falls in between the fully baked AMI and just enough operating system options. So these AMIs have some features of the baked type and some features of the just enough OS type. So as you see, the security, monitoring, logging are packed in that AMI, and the runtime environments are installed during the time of a deployment. So this is where the strict company policies would go into the AMI. Company policies like you got to log this, you got to monitor this. These are the ports that generally gets open in all our systems, stuff like that. So they strictly go into the AMI and sits in an AMI format. And during deployment, you have the flexibility of choosing the different runtime and the application that sits in an EC2 instance. Another very famous question you would face in an interview is, how can you recover login to an EC2 instance to which you lost the key? Well, we know that if the key is lost, we can't recover it. There are some organizations that integrate their EC2 instances with an AD. That's different. All right, so you can go and reset the password in the AD and you will be able to log in with the new password. But here the specific tricky question is, you are using a key to log in, and how do you recover if you have lost the key? Generally, companies would have made a backup of the key so we can pick from the backup. But here the specific question is, we have lost the key, literally no backups on the key at all. So how can we log in? And we know that we can't log into the instance without the key present with us. So the steps to recover is that make the instance use another key and use that key to log in. Once the key is lost, it's lost forever. We won't be able to recover it. You can't raise a ticket with Amazon. Not possible. They're not going to help. It's beyond the scope. So make the instance use another key. It's only the key that's the problem. You still have valid data in it. You got to recover the data. It's just the key that's having the problem. So we can actually focus on the key part alone and change the key, and that will allow us to log in. So how do we do it? Step-by-step procedure. So first, verify the EC2 config service is running in that instance. If you want, you can actually beforehand install the EC2 config in that service, or you can actually make the EC2 config run through the console. Just a couple of button clicks and that'll make the EC2 config run in that EC2 instance, and then detach the root volume for that instance. Of course, it's going to require a stop and start. So detach the root volume from the instance, attach the root volume to another instance as a temporary volume, or it could be a temporary instance that you've launched only to fix this issue, and then log in to that instance and to that particular volume and modify the configuration file. Modify it to use the new key, and then move the root volume back to its original position and restart the instance. And now the instance is going to have the new key, and you also have the new key with which you can log in. So that's how we go ahead and fix it. Now let's move on to some product specific or S3 product specific questions. A general perception is S3 and EBS can be used interchangeably, and the interviewer would want to test your knowledge on S3 and EBS. Well, EBS uses S3, that's true, but they can't be interchangeably used. So you might face this question, what are some key differences between AWS S3 and EBS? Well, the differences are, S3 is an object store, meaning you can't install anything in it. You can store drive files, but you can't actually install in it. It's not a file system. But EBS is a file system. You can install services, install applications in it, and that's going to run stuff like that. And talking about performance, S3 is much faster and EBS is super faster when accessing from the instance, because from the instance, if you need to access S3, you'll actually have to go out through the internet and access the S3, or S3 is an external service, very external service. You'll have to go through, or you'll have to go outside of your VPC to access S3. S3 does not come under a VPC, but EBS comes under a VPC. It's on the same VPC, so you would be able to use it kind of locally. Compared to S3, EBS is very local, so that way it's going to be faster. And redundancy, talking about redundancy of S3 and EBS, S3 is replicated. The data in S3 is replicated across the data centers, but EBS is replicated within the data center, meaning S3 is replicated across availability zones. EBS is within an availability zone. So that way redundancy is a bit less in EBS. In other words, redundancy is higher in S3 than EBS. And talking about security of S3, S3 can be made private as well as public, meaning anybody can access S3 from anywhere in the internet. That's possible with S3. But EBS can only be accessed when attached to an EC2 instance. Right, just one instance can access it, whereas S3 is publicly directly accessible. The other question related to S3 security is, how do you allow access to a user to a certain bucket, which means this user is not having access to S3 at all, but this user needs to be given access to a certain bucket. How do we do it? The same case applies to servers as well. In few cases, there could be an instance where a person is new to the team and you actually don't want them to access the production service. Now he is in the production group and by default he or she is granted access to that server, but you specifically want to deny access to that production server till the time he or she is matured enough to access or understand the process, understand the do's and don'ts before they can put their hands on the production server. So how do we go about doing it? So first we would categorize our instances. Well, these are critical instances. These are normal instances. And we would actually put a tag on them. That's how we categorize, right? So you put a tag on them. Put a tag saying, well, they are highly critical, they are medium critical, and they are not critical at all. Still they're in production, stuff like that. And then you would pick the users who wants to or who should be or should not be given access to a certain server. And you would actually allow the user to access or not access servers based on a specific tag. In other words, you can use actually tags. In the previous step, we put tags on the critical server, right? So you would define that this user is not going to use this tag. All right, this user is not allowed to use the resources with this tag. So that's how you would make your step forward. So you would allow or deny based on the tags that you have put. So in this case, he or she will not be allowed to servers which are tag critical servers. So that's how you deny access to them. And the same goes for bucket as well. But if an organization is excessively using S3 for their data storage because of the benefit that it provides, the cost and the durability, you might get asked this question, which is organizations would replicate the data from one region to another region for additional data durability and for having data redundancy. Not only for that, they would also do that for DR purposes, for disaster recovery. If the whole region is down, you still have the data available somewhere else and you can pick and use it. Some organizations would store data in different regions for compliance reasons, to provide low latency access to their users who are local to that region, stuff like that. So when companies do replication, how do you make sure that there is consistency in the replication? How do you make sure that the replication is not failing and the data gets transferred for sure and there are logs for that replication? This is something that the companies would use where they're excessively using S3 and they're fully relying on the replication in running their business. And the way we could do it is we can set up a replication monitor. It's actually a set of tools that we could use together to make sure that the cloud replication, region level replication is happening properly. So this is how it happens. Now on this side, on the left hand side, we have the region 1 and on the right hand side, we have region 2. And region 1 is the source bucket and region 2 is the destination bucket. All right, so object is put in the source bucket and it has to go directly to the region 2 bucket or made a copy in the region 2 bucket. And the problem is sometimes it fails and there is no consistency between them. So the way you would do it is connect these services together and create an cross-replication or cross-region replication monitor that actually monitors your environment. So there are CloudWatch that make sure that the data is moved, no data is failing. Again, there's CloudWatch on the other end, make sure that the data is moving. And then we have the logs generated through CloudTrail, and that's actually written in DynamoDB. And if there is an error, if something is failing, you get notified through an SMS or you get notified through an email using the SNS service. So that's how we could leverage these tools and set up an cross-region replication monitor that actually monitors your data replication. Some common issues that companies face in VPC is that we all know that I can use Route 53 to resolve an IP address externally from the internet, but by default the servers won't connect to the other servers using our custom DNS name. That it does not do that by default. So it's actually a problem. There are some additional things that as an administrator or as an architect or as a person who uses it, you will have to do. And that's what we're going to discuss. So the question could be, VPC is not resolving the server through the DNS. You can access it through the IP, but not through the DNS name. And what could be the issue and how do you go about fixing it? And you will be able to answer this question only if you have done it already. It's a quick and simple step. By default, VPC does not allow, that's the default feature, and we will have to enable the DNS hostname resolution before. Now this is for the custom DNS, not for the default DNS that comes along. This is for the custom DNS. So we will have to enable the DNS hostname resolution. So we'll have to enable the DNS hostname resolution so they actually resolve. Let's say I want to connect to server1.simplylearn.com. By default, it's not allowed. But if I enable this option, then I will be able to connect to server1.simplylearn.com. If a company has VPCs in different regions and they have a head office in a central place and the rest of them are branch offices and they are connecting to the head office for access or for saving data or for accessing certain files or certain data or storing data, all right, so they would actually mimic the hub and spoke topology where you have the VPC which is centrally in an accessible region, a centrally accessible region, and then you would have a local VPCs or branch offices in different other regions, and they get connected to the VPC in the central location. And the question is, how do you actually connect the multiple sites to a VPC and make communication happen between them? By default, it does not do that. We know that VPCs, they need to be peered between them in order to access the resources. Let's look at this picture, right? So I have like a customer network or branch offices in different parts, and they get connected to a VPC. That's fine. So what we have achieved is those different offices, the remote offices, they are connecting to the VPC and they're talking, but they can't connect or they can't talk to each other. That's what we have built. But the requirement is the traffic needs to, or they should be able to talk to each other, but they should not have a direct connection between them, which means that they will have to come and hit the VPC and then reach the other customer network, which is in Los Angeles or which is in New York. Right? That's the requirement. So that's possible with some architecting in the cloud. So that's using VPN Cloud Hub. You look at these dotted lines, which actually allows customers or which actually allows the corporate networks to talk to each other through the VPC. Again, by default, it doesn't happen. Cloud Hub is an architecture that we should be using to make this happen. And what's the advantage of it? As a central office or as the headquarters office, which is in the VPC, or headquarters data center, which is in the VPC, you have control, or the VPC has control on who talks to who and what traffic can talk to, what traffic can be routed to the other head office, stuff like that. That centralized control is on the VPC. The other question you could get asked is, name and explain some security products and features available in VPC. Well, VPC itself is an security service. It provides security service to the application, but how do you actually secure the VPC itself? That's the question. And yes, there are products that can actually secure the VPC, or the VPC delivers those products to secure the application. Access to the VPC is restricted through a network access control list. Right? So that's an security product in VPC. And a VPC has security groups that protects the instances from unwanted inbound and outbound traffic, and network access control list protects the subnets from unwanted inbound and outbound access. And there are flow logs we can capture in VPC that captures incoming and outgoing traffic through a VPC, which will be used for later analysis, as in what's the traffic pattern, what's the behavior of the traffic pattern, stuff like that. So there are some security products and features available in VPC. Now, how do you monitor VPC? VPC is a very important concept, very important service as well. Everything sits in a VPC. Most of the service sits in a VPC. except for Lambda and S3 and DynamoDB and a couple of other services. Most of them sit in a VPC for security reasons. So how do you monitor your VPC? How do you gain some visibility on your VPC? Well, we can gain visibility on our VPC using VPC flow log. That's the basic service. As you see, it actually captures what's allowed, what's not allowed, stuff like that. Which IP is allowed, which IP is not allowed, stuff like that. So we can gather it and we can use that for analysis. And the other one is CloudWatch and CloudWatch logs, the data transfers that happen. So this is who gets allowed and who does not get allowed. I mean, the flow logs is who is allowed and who's not allowed, that kind of detail. And CloudWatch gives information about the data transfer, how much data is getting transferred. We can actually pick unusual data transfers if there is a sudden hike in the graph. There's a sudden hike and something happens at 12 on a regular basis and you weren't expecting it. There's something suspicious. It could be valid backups. It could be a malicious activity as well. So that's how you know, by looking at CloudWatch logs and CloudWatch dashboard.
Now let's talk about multiple choice questions. When going for an interview, you might sometimes find yourself that the company is conducting an online test. Based on the score, they can put you to a panelist and then they would take it forward. So we thought we'll also include multiple choice questions to help you better handle such situation if you come across. Alright, when you find yourself in such situation, the key to clear them is to understand the question properly, read between the lines. That's what they say. There can be like a big paragraph with 3 lines or 10 lines. You really got to understand what the question is about and then try to find answer for that question. So that's a thumb rule number 1. And then the second rule is try to compare and contrast the services mentioned, or try to compare and contrast the answers. You can easily weed out 1 or 2 answers and then you will be left with only 2 answers to decide from. So that also helps you with time, and that also helps you with some precision in your answer. So number 1, read between the lines. Number 2, compare and contrast the services, and you'll be able to easily weed out the wrong ones. So let's try answering this question. Suppose you are a game designer and you want to develop a game with a single digit millisecond latency. Which of the following database services would you choose? So we know that the following are database services. Good enough. All right. And it talks about millisecond latency. That's a key point. And the third thing is it's a game. Could be a mobile game. It's a game that you are trying to design and you need millisecond latency and it has to be a database. Alright, so let's talk about the options available. RDS. RDS is a database for sure. Is it good for game design? We'll come back to that. Neptune. Neptune is a graph, a database service in Amazon. So that's kind of out of the equation. And Snowball is actually a storage. Alright, it's a transport medium, I would say. So that's again out of the equation. So the tie is between RDS and DynamoDB. So if we need to talk about RDS is a platform as a service. It provides cost-efficient, resizable capacity, but it's an SQL database, meaning the tables are kind of strict. It's good for banking and other type of applications, but not really good for anything that has to do with gaming. So the only option left is DynamoDB. Again, it's the right answer. DynamoDB is actually an fast and flexible NoSQL database service, and it provides a single-digit millisecond latency at any scale. And it's a database at the same time. It's a key value store model database. So the right answer is DynamoDB. All right. Let's look at the next question. If you need to perform real-time monitoring of AWS services and get actionable insights, which service would you use? Alright, let's list the services. So it talks about real-time monitoring. A firewall manager, what does it provide? Now, firewall manager is not really a monitor, just like the name says, it's a manager. It manages multiple firewalls. And AWS Guard Duty is an threat detection service. It does monitoring. It does continuously monitor our environment, but it monitors for threats. All right, only threats. Now let's talk about CloudWatch. CloudWatch is a service that helps to track metrics. It's a service that is used to monitor the environment and give us a system-wide visibility, and also it helps us to store logs. So at the moment it kind of looks like that could be the right answer. We don't know that yet, but I mean, we have one more option left, that's EBS. So what's EBS? EBS is a block storage, elastic block store. If we abbreviate EBS, it's elastic block store. So all three of them are easily out of the question. The first one is to manage, second one is to find threats. Of course, it does monitoring. So there's, if there is one relation between CloudWatch and guard duty, that's monitoring. So easily we can actually find ourselves slipped towards picking guard duty, but know that guard duty is only for gaining security insight, but not about gaining AWS service insight. So CloudWatch is a service that helps us to get a system-wide or an AWS-wide or an account-wide, and it has a number of metrics we can monitor and get a very good insight of how a service is performing, be it CPU, be it RAM, be it network utilization, be it connection failures. CloudWatch is a service that helps us perform a real-time monitoring and get some actionable insights on the services. Alright, let's talk about this 33rd question. As a web developer, you are developing an app especially for the mobile platform. Alright, there is a mention that this is especially for the mobile platform. So a lot of services gets filtered out, mobile platform. Right, which of the following lets you add user sign up, sign in, and access control to your web and mobile app quickly and easily? Alright, so this is all about signing in to your mobile app. So if we need to read between the lines, that's how we can read sign up or sign in into an mobile platform. Alright, so we have like four options here: Shield, AWS Massey, AWS Inspector, Amazon Cognito. So let's try to weed out services which are not relevant to it. So what's AWS Shield? AWS Shield is actually a service that provides a DDoS mitigation or a DDoS protection, denial of service protection. It's a security feature. Let's talk about the second option. AWS Massey is again a security service that uses machine learning to automatically discover and classify the data. It again talks about security, and this security is all about encrypting or saving the data. It does not come close with signing up an mobile platform. Alright, let's talk about the other one, AWS Inspector. Now, AWS Inspector has something to do with apps. It definitely has something to do with apps. So kind of looks like that's relevant as of now. So it actually helps with improving the security and compliance of the apps that we deploy in the cloud. So kind of looks like it could be because it has to do with apps. The last one, Cognito. Now, Cognito is a service that actually lets the administrator to have control access over web and mobile apps. And it's a service that helps us to sign up and sign in to an mobile and web app. So that very much looks like we found the answer. So Cognito is a service that helps web app and mobile app for sign up and signing in, and also gives the administrator to have control over access control over the web and the mobile app. Pretty much we found it. So it's Cognito. Cognito is a service that helps us to set up, sign in, and have access control over the users who would be using our mobile and web app. Alright, how about this question? You are an ML engineer or a machine learning engineer who's on the lookout for a solution that will discover sensitive information that your enterprise stores in AWS and then uses NLP to classify that data and provide business related insights. Which among the following services would you choose? So we have a bunch of services that's going to help us achieve, or one of it is going to help us achieve the above requirement. So it's a service that deals with machine learning. You're a machine learning engineer who's looking for a service that will help you to discover information at your enterprise store. So we're talking about storage, discover information in store, and then classify the data depending on severity, the sensitivity, classify the data. So which service is that? So firewall manager, just like the name says, it's a manager. And AWS IAM, if we abbreviate it, it's identity and access management. So it's identity and access management, nothing to do with identifying sensitive data and managing it. So the first two is already out of the equation. And then the AWS Massey, we already had a quick definition description for AWS Massey that it's actually a security service that uses machine learning. Kind of looks like it could be it. It's a security service that uses machine learning, and it discovers and classifies the sensitive information. Not only that, it does not stop there. It goes beyond and protects the sensitive data. AWS Massey kind of looks like. But we still have one more option to look at, which is Cloud HMS. Cloud HMS is also a security service. Kind of looks like that could be the answer as well. And it enables us to generate encryption keys and save the data. So kind of 50% of it. It's a security service. It encrypts, helps us protect the data, but AWS Massey is right on spot. It's a machine learning service. It helps us to classify the data and also to protect the data. So the answer for this question would be AWS Massey. So hope you kind of get it how this is going. So first we apply the thumb rule, identify the question that's being asked, read between the lines, and then try to find the service that meets your requirement. And finding the service is by first weeding out the wrong ones, recollect everything that you've learned about the service and see how well that matches with those hints that you have picked up. And if that doesn't match, weed that out, and you'll end up with just two to decide from at some point, and then it becomes easy for you to decide. Click on the question, submit it, and then move on to the other question in your interview. Alright, so how about this one? You are a system administrator in a company which is running most of its infrastructure on AWS. You are required to track your users and keep a look on how your users are being authenticated. Alright, so this is where the problem statement starts. Alright, you need to keep track of how your users are being authenticated, and you wish to create and manage AWS users and use permissions to allow and deny their access to the AWS resources. Alright, so you are to give them permission, number one, and then, if we put them in the right order, first giving them permissions and then tracking their usage. Let's see which of the service will help us achieve it. IAM is a service that helps us to, looking at the permissions, we can actually predict whether the user or the group will have service or not. So that helps us to get a track of who is able to use, who's not able to use certain service and all that stuff. So it kind of looks like, but we have other three options left. Let's look at AWS Firewall Manager. Just like the name says, it's actually a firewall manager. It helps us to manage multiple firewalls. Simple as that. And Shield is a service. It's a service that's used to protect denial of service or distributed denial of service. An API Gateway is a service that makes it easy for developers to create, publish, maintain, and monitor and secure APIs. So, it's completely on the API side, very less on user and how you authenticate your user. We can get that by looking at the name itself, right? If we abbreviate it, or if you try to find a definition for the name API Gateway, you would get it. It has to do with API. But if we abbreviate AWS IAM, it's Identity and Access Management, pretty much meets the requirement for the problem statement above. It's AWS Identity and Access Management. That's the right answer. Alright, let's look at this one. If you want to allocate various private and public IP address in order to make them communicate with the internet and other instances, you will use this service. Which of the following is this service? So it talks about using public and private IP address. So this service uses IP address, and then this service helps us to allow and deny connections to the internet and to the other instances. So you get the question, is it? Let's pick the service that helps us achieve it. Route 53. Route 53 is actually a DNS service, right? So it's not a service that's used to allow or deny. No, it does not do that. VPC uses public and private IP address. Yes. So kind of looks like VPC helps us to allow, the security in VPC, the security group, the network access control list in a VPC, the routing table in a VPC, that actually helps us to allow or deny a connection to a particular IP address or to a particular service within the VPC or outside of the VPC. So as of now, it kind of looks like it could be, but let's look at the other services. What if we find a service that closely matches to the above requirement than the Amazon VPC? Gateway, API Gateway, we know that it's a managed service that makes it easy for developers to create, publish, maintain, and monitor APIs. and secure API. So that has completely to do with API, not with IP. Cloudfront, we know about Cloudfront that it's a content delivery network and it provides global distribution of servers where our content can be cached. It could be video or bulk media or anything else. They can be cached locally so users can easily access them and download them easily. All right, so that's Cloudfront. Now at this point, after looking at all four, it looks like VPC is the right answer, and in fact VPC is the right answer. VPC has public IP address. VPC can help us with private IP address. VPC can be used to allow deny connection based on the security group, access control list, and the routing table it has. So that's right answer is VPC. Alright, how about this one? This platform as a service or platform as a DB service provides us with a cost-efficient and resizable capacity while automating time-consuming administrative tasks. So this question is very clear. It's a DB service we got to look for, and it's a service that can provide automating some of the time-consuming tasks. It has to be resizable at the same time. So let's talk about Amazon Relational Database. It's a database. Kind of matches the requirement. We can resize it as and when needed. All right, looks like it's a fit as of now. It actually automates some of the time consuming work. Looks like it's a fit as of now. Let's move on to Elastic Cache and then try to see if that matches the definition that we've figured out above. Elastic Cache, it's actually a caching service. It's again an in-memory data store which helps in achieving high throughput and low latency in memory data store. So it's not a full-blown database and it does not come with any Amazon provisioned automation in it for automating any of the administration tasks. No, it does not come up with anything like that. Yeah, we can resize the capacity as and when needed, but automation, it's not there yet, and moreover it's not a database. So that's out of the equation. VPC is not a resizable one. Once we have designed VPC, it's fixed. It can't be resized. So that's out of the equation. And Amazon Glacier is a storage but not a database. Right, so that's again out of the equation. So the tie is kind of between Amazon Relational Database Service and Amazon Elastic Cache because they both aid the database service, but Elastic Cache is not a full-blown database. It actually helps the database, but it's not a full-blown database. So it's Amazon Relational Database. So that's the one which is a platform as a service. It's the one which can be resized. It's the one which can be used to automate the time-consuming administrative tasks. Alright, let's talk about this one. Which of the following is a means for accessing human researchers or consultants to help solve a problem on a contractual or a temporary basis? Alright, let's read the question again. Which of the following is a means for accessing human researchers or consultant to help solve problems on a contractual or a temporary basis? It's like assigning tasks or hiring AWS experts for a temporary job. So let's try to find that kind of service in the four services that are listed. Amazon Elastic MapReduce. MapReduce is actually an framework service that makes it easy and cost effective to analyze large amount of data, but that has nothing to do with accessing human researchers. Alright, let's talk about Mechanical Turk. It's a web service that provides a human workforce. That's the definition for it. For example, automation is good, but not everything can be automated. For something to qualify for automation, it has to be a repetitive task. A one-time task can't be automated, or the time and money that you would be spending in automation is not worth it. Instead, you could have done it manually. So that does not qualify for automation. And anything that requires intelligence, right? Anything that's a special case. Right? Automation can do repetitive tasks. Automation can do precise work, but it has to be a repetitive task. The scenario, it should have been there already. Only then that can be executed. But if it's a new scenario and it requires appropriate addressing, then it requires human task. So we could hire researchers and consultants who can help solve a problem using Amazon Mechanical Turk. The other two are already out of the equation. Now DevPay is actually a payment system through Amazon, and multi-factor authentication, as it says, it's an authentication system. So the right answer is Amazon Mechanical Turk. Alright, this sounds interesting. Let's look at this one. This service is used to make it easy to deploy, manage, and scale containerized applications using Kubernetes on AWS. Which of the following is this AWS service? So it's a service to deploy, manage, and scale containerized applications. So it deals with containers. It also should have the ability to use Kubernetes, which is a container orchestration service. Alright, the first one, Amazon Elastic Container Service. Kind of looks like it's the one. The name itself has the word and the relation we're looking for, Elastic Container Service. So this container service is an highly scalable, high performance container orchestration service. Let's look at the other one, AWS Batch. It's a service that enables IT professionals to schedule and execute batch processing. I mean, the name itself says that that's meant for batch processing. Elastic Beanstalk, that's another service that helps us to deploy, manage, and scale, but it helps us with EC2 instances, not with containerized instances. So that's again out of the equation. Would Lightsail be a good tie for Elastic Container Service? What's Lightsail? Now, Lightsail is a service. It's called as a virtual private server without a VPC. It's called as a virtual private server. It comes with predefined compute, storage, networking capacity. It's actually a server, not a container. Right, so at this point that also becomes out of the equation. So it's Amazon Elastic Container Service. That's the one that helps us to easily deploy, manage, scale container services, and it helps us orchestrate the containers using Kubernetes. Alright, how about this one? Alright, this service lets us to run code without provisioning or managing servers. So no servers, run code. Select the correct service from the below option. Alright, so no servers, but we should be able to run code. Amazon EC2 Autoscaling. EC2 Autoscaling? EC2 is Elastic Compute Cloud, which is a server, and Autoscaling is a service that helps us to achieve scaling the server. So that's the definition for it. Could be that's out of the equation. AWS Lambda. Now Lambda is a service. It's actually an event-driven serverless computing platform, and Lambda runs code in response to the event that it receives, and it automatically manages the compute resource that's required for that code. As long as we have uploaded a code that's correct and set up events correctly to map to that code, it's going to run seamlessly. So that's about Lambda. It kind of looks like it could be the answer because Lambda runs code. We don't have to manage servers. It manages servers by itself. But we can't conclude as of now. We have other two services to talk about. AWS Batch. Alright, Batch is a service that enables IT professionals to run batch job. We know that. And about Inspector, Amazon Inspector, it's actually a service that helps us to increase and identify any security issues and align our application with compliance. Well, that's not the requirement in the question. The requirement in the question was run code without provisioning a server, and without any more space for confusion, AWS Lambda is a service, or is the service that runs code without provisioning and managing services. Right? The right one would be AWS Lambda.
Alright, let's get started. So in an environment where there is a lot of automation, infrastructure automation, you'll be posted with this question: how can you add an existing instance to a new autoscaling group? Now this is when you are taking an instance away from the autoscaling group to troubleshoot, to fix a problem, to look at logs, or if you have suspended the autoscaling, you might need to re-add that instance to the autoscaling group. Only then it's going to take part in it, right? Only then the autoscaling is going to count it as part of it. It's not a straight procedure. When you remove them, it doesn't get automatically re-added. And I've worked with some clients when their developers were managing their own environment, they had problems adding the instance back to the autoscaling group. Irrespective of what they tried, the instance was not getting added to the autoscaling group, and whatever they fix that they were provided, or whatever fix that they have provided, were not getting counted in the autoscaling group. So like I said, it's not a straight a click button procedure. There are ways we'll have to do it. So how can you add an existing instance to the autoscaling group? There are a few steps that we need to follow. So the first one would be to, under the EC2 instance console, right, under the instance, under actions in specific, there's an option called attach to autoscaling group, right? If you have multiple autoscaling groups in your account or in the region that you're working in, then you're going to be posted with the different autoscaling groups that you have in your account. Let's say you have 5 autoscaling groups for 5 different applications. You're going to be posted with 5 different autoscaling groups, and then you would select the appropriate autoscaling group and attach the instance to that particular autoscaling group. While adding to the autoscaling group, if you want to change the instance type, that's possible as well. Sometimes when you want to add the instance back to the autoscaling group, there would be requirement that you change the instance type to a better one, to a better family, to the better instance type. You could do that at that time. And after that, you have completely added the instance back to the autoscaling group. So it's actually a 7-step process, adding an instance back to the autoscaling group. In an environment where they're dealing with migrating the instance, or migrating an application, or migrating an instance, migrating an VM into the cloud, if the project that you're going to work with deals with a lot of migrations, you could be posted this question: what are the factors you will consider while migrating to Amazon Web Services? The first one is cost. Is it worth moving the instance to the cloud? Given the additional bells and whistles features available in the cloud, is this application going to use all of them? Is moving into the cloud beneficial to the application in the first place? Beneficial to the users who will be using the application in the first place. So that's a factor to think of. So this actually includes cost of the infrastructure and the ability to match the demand and supply transparency. Is this application in high demand? Is it going to be a big loss if the application becomes unavailable for some time? So there are a few things that needs to be considered before we move the application to the cloud. And then if the application needs to be provisioned immediately, is there an urge? Is there an urge to provision the application immediately? That's something that needs to be considered. If the application requires to go online, if the application needs to hit the market immediately, then we would need to move it to the cloud. Because in on-premises, procuring, buying an infrastructure, buying the bandwidth, buying the switch port, buying an instance, buying the softwares, buying the license related to it, it's going to take time, at least like 2 weeks or so, before you can bring up an server and launch an application in it, right? So if the application cannot wait, waiting means workforce productivity loss, is it? So we would want to immediately launch instances and put application on top of it. In those cases, if your application is of that type, if there is an urge in making the application go online as soon as possible, then that's a candidate for moving to the cloud. And if the application, or if the software, or if the product that you're launching, it requires hardware, it requires an updated hardware all the time, that's not going to be possible in on-premises. We try to deal with legacy infrastructure all the time in on-premises, but in the cloud, they're constantly upgrading their hardwares. Only then they can keep themselves up going in the market. So the cloud providers are constantly updating their hardwares. And if you want to be benefited, or if your application wants to be benefited by the constant upgrading of the hardwares, making sure the hardware is as latest as possible, the software version, the licensing is as latest as possible, then that's a candidate to be moved to the cloud. And if the application does not want to go through any risk, if the application is very sensitive to failures, if the application is very much tagged to the revenue of the company, and you don't want to take a chance in seeing the application fail and seeing the revenue drop, then that's a candidate for moving to the cloud. And business agility, moving to the cloud, at least half of the responsibility is now taken care by the provider. In this case, it's Amazon. At least half of the responsibility is taken care by them. Like if the hardware fails, Amazon makes sure that they're fixing the hardware immediately. And notifications, if something happens, there are immediate notifications available that we can set it up and make ourselves self-aware that something has broken, and we can immediately jump in and fix it. So you see, the responsibility is now being shared between Amazon and us. So if you want to get that benefit for your application, for your organization, for the product that you're launching, then it needs to be moved to the cloud so you can get that benefit from the cloud. The other question you could get asked is, what is RTO and RPO in AWS? They are essentially disaster recovery terms. When you're planning for disaster recovery, you cannot avoid planning disaster recovery without talking about RTO and RPO. Now, what's the RTO? What's the RPO in your environment? Or how do you define RTO? How do you define RPO? Are some general questions that get asked. RTO is recovery time objective. RTO stands for the maximum time the company is willing to wait for the recovery to happen, or for the recovery to finish when a disaster strikes. So RTO is in the future, right? How much time is it going to take to fix and bring everything to normal? So that's RTO. On the other hand, RPO is recovery point objective, which is the maximum amount of data loss your company is willing to accept as measured in time. RPO always refers to the backups, the number of backups, the frequency of the backups, right? Because when an outage happens, you can always go back to the latest backup, right? And if the latest backup was before 12 hours, you have lost the in-between 12 hours of data storage, right? So RPO is the acceptable amount. If the company wants less RPO is 1 hour, then you should be planning on taking backups every 1 hour. If RPO is 12 hours, then you should be planning on taking backups every 12 hours. So that's how RPO and RTO helps disaster recovery. The fourth question you could get asked is, if you'd like to transfer huge amount of data, which is the best option among Snowball, Edge, and Snowmobile? Again, this is a question that gets asked if the company is dealing with a lot of data transfer into the cloud, or if the company is dealing with migrating data into the cloud. I'm talking about a huge amount of data in petabytes. Snowball and all of the Snowball series deals with petabyte-sized data migrations. So there are three options available as of now. AWS Snowball is an data transport solution for moving high volume of data into and out of a specified AWS region. On the other hand, AWS Snowball Edge adds additional computing functions. Snowball is simple storage and movement of data, and Snowball Edge has a compute function attached to it. Snowmobile, on the other hand, is an exabyte scale migration service that allows us to transfer data up to 100 petabytes. That's like 100,000 terabytes. So depending on the size of data that we want to transfer from our data center to the cloud, we can rent any of these three services. Let's talk about some CloudFormation questions. This is a classic question. How is AWS CloudFormation different from AWS Elastic Beanstalk? From the surface, they both look like the same. You don't go through the console provisioning resources. You don't go through CLI and provision resources. Both of them provision resources through click button, right? But underneath, they are actually different services. They aid different services. So knowing that is going to help you understand this question a lot better. Let's talk about the difference between them, and this is what you will be explaining to the interviewer or the panelist. So the CloudFormation service helps you describe and provision all the infrastructure resources in the cloud environment. On the other hand, Elastic Beanstalk provides an simple environment to which we can deploy and run application. CloudFormation gives us an infrastructure, and Elastic Beanstalk gives us a small contained environment in which we can run our application. And CloudFormation supports the infrastructure needs of many different types of application, like the enterprise application, the legacy applications, and any new modern application that you want to have in the cloud. On the other hand, the Elastic Beanstalk, it's a combination of developer tools. They are tools that helps manage the lifecycle of a single application. So CloudFormation, in short, is managing the infrastructure as a whole, and Elastic Beanstalk in short, is managing and running an application in the cloud. And if the company that you're getting hired is using CloudFormation to manage their infrastructure, or if they're using infrastructure or any of the infrastructure as a code services, then you would definitely face this question: what are the elements of an AWS CloudFormation template? So it has 4 or 5 basic elements, right? And the template is in the form of JSON or in YAML format. Right, so it has parameters, it has outputs, it has data, it has resources, and then the format or the format version or the file format version for the CloudFormation template. So parameter is nothing but it actually lets you to specify the type of EC2 instance that you want, the type of RDS that you want, right? So EC2 is an umbrella, RDS is an umbrella, and parameters within that EC2 and parameters within that RDS are the specific details of the EC2 or the specific details of the RDS service. So that's what parameters in a CloudFormation template. And then the element of the CloudFormation template is outputs. For example, if you want to output the name of an S3 bucket that was created, if you want to output the name of the EC2 instance, if you want to output the name of some resources that have been created, instead of looking into the template, instead of navigating through in the console and finding the name of the resource, we can actually have them outputted in the result section. So you can simply go and look at all the resources created through the template in the output section, and that's what output values or output does in the CloudFormation template. And then we have resources. Resources are nothing but what defines what are the cloud components or cloud resources that will be created through this CloudFormation template. Now, EC2 is a resource, RDS is a resource, and S3 bucket is a resource, Elastic Load Balancer is a resource, and NAT Gateway is a resource, VPC is a resource. So you see, all these components are the resources, and the resource section in the CloudFormation defines what are the AWS cloud resources that will be created through this CloudFormation template. And then we have version. Version actually identifies the capabilities of the template. We just need to make sure that it is of the latest version type, and the latest version is 0909 2010. That's the latest version number. You'll be able to find that on the top of the CloudFormation template, and that version number defines the capabilities of the CloudFormation template. So just need to make sure that it's the latest all the time. Still talking about CloudFormation, this is another classic question: what happens when one of the resources in a stack cannot be created successfully? Well, if the resource in a stack cannot be created, the CloudFormation automatically rolls back and terminates all the resources that was created using the CloudFormation template. So whatever resources that were created through the CloudFormation template from the beginning, let's say we have created like 10 resources and the 11th resource is now failing, CloudFormation will roll back and delete all the 10 resources that were created previously. And this is very useful when the CloudFormation cannot go forward. CloudFormation cannot create additional resources because we have reached the elastic IP limits. Elastic IP limit per region is 5, right? And if you have already used 5 IPs and your CloudFormation is trying to buy 3 more IPs, we've hit the soft limit. Till we fix that with Amazon, CloudFormation will not be able to launch additional resources and additional IPs. So it's going to cancel and roll back everything. That's true with a missing EC2 AMI as well. If an AMI is included in the template but the AMI is not actually present, then CloudFormation is going to search for the AMI, and because it's not present, it's going to roll back and delete all the resources that it created. So that's what CloudFormation does. It simply rolls back all the resources that it created. I mean, if it sees a failure, it would simply roll back all the resources that it created. And this feature actually simplifies the system administration and layered solutions built on top of AWS CloudFormation. So at any point, we know that there are no orphan resources in our environment, because something did not work, or because there was an CloudFormation executed there are no orphan resources in our account. At any point, we can be sure that if CloudFormation is launching a resource and if it's going to fail and it's going to come back and delete all the resources it's created, so there are no orphan resources in our account. Now let's talk about some questions in Elastic Block Store. Again, if the environment deals with a lot of automation, you could be thrown this question: how can you automate EC2 backup using EBS? It's actually a 6-step process. To automate the EC2 backups, we'll need to write a script to automate the below steps using AWS API. And these are the steps that should be found in the scripts. First, to get the list of instances, and then the script that we are writing should be able to connect to AWS using the API and list the Amazon EBS volumes that are attached locally to the instance. And then it needs to list the snapshots of each volume, make sure the snapshots are present, and it needs to assign a retention period for the snapshot, because over time the snapshots are going to be invalid, right? Once you have some 10 latest snapshots, any snapshot that you have taken before that 10 becomes invalid because you have captured the latest, and 10 snapshot coverage is enough for you. And then the fifth point is to create a snapshot of each volume, create a new snapshot of each volume, and then delete the old snapshot. Anytime a new snapshot gets created, the oldest snapshot in the list needs to go away. So we need to include options, we need to include scripts in our script, lines in our script that make sure that it's deleting the older snapshots which are older than the retention period that we are mentioning. Another question that you could see in the interview, be it a written interview, be it online interview, or be it an telephonic or face-to-face interview, is what's the difference between EBS and Instant Store? Let's talk about EBS first. EBS is kind of permanent storage. The data in it can be restored at a later point. When we save data in EBS, the data lives even after the lifetime of the EC2 instance. For example, we can stop the instance and the data is still going to be present in EBS. We can move the EBS from one instance to another instance and the data is simply going to be present there. So EBS is kind of permanent storage when compared to instance. On the other hand, instance store is temporary storage, and that storage is actually physically attached to the host of the machine. EBS is an external storage, and instance store is locally attached to the instance, or locally attached to the host of the machine. We cannot detach an instance store from one instance and attach it to another, but we can do that with EBS. So that's a big difference. One is permanent data, and another one is EBS is permanent, instance store is volatile data, and instance store, with instance store we won't be able to detach the storage and attach it to another instance. And another feature of instance store is data in an instance store is lost if the disk fails or the instance is stopped or terminated. So instance store is only good for storing cache data. If you want to store permanent data, then we should think of using EBS and not instance store. While talking about storage on the same lines, this is another classic question. How can you take backups of EFS like EBS? And if you can take backup, how do you take that backup? The answer is yes, we can take EFS to EFS backup solution. EFS does not support snapshot. Like EBS, EFS does not support snapshot. Snapshot is not an option for EFS, Elastic File System, right? We can only take backup from one EFS to another EFS, and this backup solution is to recover from unintended changes or deletions of the EFS, and this can be automated. Right? Any data that we store in EFS can be automatically replicated to another EFS, and once this EFS goes down or gets deleted, or data gets deleted, or the whole EFS is for some reason interrupted or deleted, we can recover the data we can use the other EFS and bring the application to consistency. And to achieve this, it's not an one-step configuration, it's a cycle. There are a series of steps that's involved before we can achieve EFS to EFS backup. The first thing is to sign in to the AWS Management Console, and under EFS, or click on EFS to EFS restore button from the services list. And from there, we can use the region selector in the console navigation bar to select the actual region in which we want to work on. And from there, ensure that we have selected the right template. Some of the templates would be, EFS to EFS backup, granular backups, incremental backups. Right, so there are some templates, the kind of backups that you want to take. Do you want to take granular? Do you want to take increment backups? Stuff like that. And then create a name to that solution, the kind of backup that we have created. And finally, review all the configurations that you have done and click on save. And from that point onwards, the data is going to be copied. And from that point onwards, any additional data that you put is going to copy it and replicate it. Now you have an EFS to EFS backup. This is another classic question in companies which deals with data management. There are easy options to create snapshots, but deleting snapshots is not always an click button or a single step configuration. So you might be facing a question like, how do you auto delete old snapshots? And the procedure is like this. Now, as best practice, we will take snapshots of EBS volume to S3. All snapshots get stored in S3. We know that now. And we can use AWS Ops Automator to automatically handle all snapshots. The Ops Automator service, it allows us to create, copy, delete EBS snapshots. So there are CloudFormation templates available for AWS Ops Automator, and this Automator template will scan the environment and it would take snapshots. It would copy the snapshot from one region to another region if you want, if you're setting up a DR environment. And not only that, based on the retention period that we create, it's going to delete the snapshots which are older than the retention period. So life or managing snapshot is made a lot easier because of this Ops Automator CloudFormation template. Moving into questions in Elastic Load Balancer, this again could be a question in the interview. What are the different types of load balancers in AWS and what's their use case? What's the difference between them? And as of now, as we speak, there are three types of load balancers which are available in AWS. The first one being application load balancer. Just like the name says, the application load balancer works on the application layer and deals with HTTP and HTTPS requests. And it also supports path-based routing. For example, simplilearn.com / some web page, simplilearn.com / another website. So it's going to direct the path based on the / value that you give in the URL. So that's path-based routing. So it supports that. And not only that, it can support port-based :8080, :8081, or :8090. Based on that port also, it can take a routing decision, and that's what application load balancer does. On the other hand, we have network load balancer, and the network load balancer makes routing decisions at the transport level. It's faster because it has very less thing to work on. It works on lower OSI layer. It works on a lower layer, so it has very less information to work with than compared with application layer. So comparatively, it's a lot faster and it handles millions of requests per second. And after the load balancer receives a connection, it selects a target group for the default rule using the flow hash routing algorithm. It does simple routing, right? It does not do path-based or port-based routing. It does simple routing, and because of it, it's faster. And then we have classic load balancer, which is kind of expiring as we speak. Amazon is discouraging people using classic load balancer, but there are companies which are still using classic load balancer. They are the ones who were the first one to step into Amazon when classic load balancer was the first load balancer or the only load balancer available at that point. So it supports HTTP, HTTPS, TCP, SSL protocol, and it has a fixed relationship between a load balancer port and the container port. So initially we only had classic load balancer, and then after some point Amazon said, instead of having one load balancer address all type of traffic, we're going to have two load balancers called as the child from the classic, two load balancer, and one is going to specifically address the application requirement and one is going to specifically address the network requirement, and let's call it as application load balancer and network load balancer. So that's how now we have two different load balancers. Talking about load balancer, another classic question could be, what are the different uses of the various load balancer in AWS Elastic load balancing? There are three types of load balancer. We just spoke about it. Application load balancer is used if we need flexible application management and TLS termination, and network load balancer if we require extreme performance and the load balancing should happen based on static IPs for the application. And classic load balancer is an old load balancer which is for people who are still running their environment from EC2 classic network. Now this is an older version of VPC, or this is what was present before VPC was created. EC2 classic network is what was present before EC2 was created. So they are the three types and they are the use cases of it. Let's talk about some of the security related questions you would face in the interview. When talking about security and firewall in AWS, we cannot avoid discussion talking about WAF, Web Application Firewall, and you would definitely see yourself in this situation where you've been asked how can you use AWS WAF in monitoring your AWS applications. WAF or Web Application Firewall protects our web application from common web exploits, and WAF helps us control which traffic source your application should be allowed or blocked, which traffic from a certain source, which source or which traffic from a certain source should be allowed or blocked your application. With WAF we can also create custom rules that blocks common attack patterns. If it is a banking application, it has a certain type of attacks, and if it is simple data management, data storage application, it has content management application, it has a separate type of attack. So based on the application type, we can identify a pattern and create rules that would actually block that attack based on the rule that we create. And WAF can be used for three cases. The first one is allow all requests, and then block all requests, and count all requests for a new policy. So it's also an monitoring and management service which actually counts all the policies, or counts all the requests that matches a particular policy that we create. And some of the characteristics we can mention in AWS WAF are the origin IPs and the strings that appear in the request. We can allow block based on origin IP, allow block based on strings that appear in the request. We can allow block or count based on the origin country, length of the request. We can block and count the presence of malicious scripts in an connection. We can count the request headers, or we can allow block a certain request header, and we can count the presence of a malicious SQL code in a connection that we get and that want to reach our application. Still talking about security, what are the different AWS IAM categories we can control? Using AWS IAM, we can do the following. One is create and manage IAM users, and once the user database gets bigger and bigger, we can create and manage them in groups. And in IAM, we can use it to manage the security credentials, kind of setting the complexity of the password, setting additional authentications, like MFA, and rotating the passwords, resetting the password. There are a few things we could do with IAM. And finally, we can create policies that actually grants access to AWS services and resources. Another question you will see is, what are the policies that you can set for your user's password? So some of the policies that we can set for the user password is the minimum length, or the complexity of the password by at least having one number or one special characters in the password. So that's one. And then the requirement of a specific character types, including uppercase, lowercase, number, and non-alphabetic characters. So it becomes very hard for somebody else to guess what the password would be and try to hack them. So we can set the length of the password, we can set the complexity in the password, password, and then we can set an automatic expiration of the password. So after a certain time, the user is forced to create a new password, so the password is not stale, old, and easy to guess in the environment. And we can also set settings like the user should contact the admin, when the password is about to expire. So you can get a hold of how the user is setting their password. Is it having good complexity in it? Is it meeting company standards? Or there are a few things that we can control and set for the users when the users are setting or recreating the password. Another question that could be posted in an interview, so to understand your understanding of IAM, is what's the difference between an IAM role and an IAM user? Let's talk about IAM user. Let's start small and then go big, or let's start simple and then talk about the complex one. The IAM user has a permanent long-term credential, and it's used to interact directly with AWS services. And on the other hand, IAM role is an IAM entity that defines a set of permissions for making AWS service requests. So IAM user is an permanent credential and role are temporary credentials. And IAM user has full access to all AWS IAM functionalities. And with role, trusted entities such as IAM users, application, or AWS services assume the role. So when an IAM user is given a permission, it sticks within the IAM user. But with roles, we can give permissions to applications, we can give permissions to users in the same account, in a different account, corporate ID. We can give permissions to EC2, S3, RDS, VPC, and lot more. Role is wide, and IAM user is not so wide. It's very constrained only for that IAM user. Let's talk about managed policies in AWS. Managed policies, there are two types, customer managed and Amazon managed. So managed policies are IAM resources that express permissions using the IAM policy language. We can create policies, edit them, manage them separately from the IAM user group and roles which they are attached to. So they are something that we can do to managed policies if it is customer managed. And we can now update policy in one place, and the permissions automatically extend to all the attached entries. So I can have like 3 services, 4 services point to a particular policy, and if I edit that particular policy, it's going to reflect on those 3 or 4 services. So anything that I allow is going to be allowed for those 4 services. Anything that I denied is going to be denied for the 4 services. Imagine what would be without the IAM managed policy. We'll have to go and specifically allow deny on those different instances 4 or 5 times, depending on the number of instances that we have. So like I said, there are 2 types of managed policies. One is managed by us, which is customer managed policies, and then the other is managed by AWS, which is AWS managed policy. This question, can you give an example of an IAM policy and a policy summary? This is actually to test how well versed are you with the AWS console. The answer to that question is, look at the following policy. This policy is used to grant access to add, update, and delete objects from a specific folder. In this case, name of the folder is example folder, and it's present in a bucket called example bucket. So this is an IAM policy. On the other hand, the policy summary is a list of access level, resource, and conditions for each service defined in a policy. So IAM policy is all about one particular resource, and the policy summary is all about multiple resources. With IAM policy, it was only talking about S3 bucket and one particular S3 bucket. Here it talks about CloudFormation template, CloudWatch logs, EC2, Elastic Beanstalk services. Summary of resources and the permissions and policies attached to them. That's what policy summary is all about. Another question could be like this: what's the use case of IAM, and how does IAM help your business? Now, 2 important or primary work of IAM is to help us manage IAM users and their access. It provides secure access to multiple users to their appropriate AWS resources. So that's one it does. And the second thing it does is manage access for federated users. Federated users or non-IAM users, and through IAM we can actually allow and provide secure access to resources in our AWS account to our employees without the IAM user. Now, they could be authenticated using the Active Directory. They could be authenticated using the Facebook credential, Google credential, Amazon credential, and a couple of other credentials, third-party identity management, right? So we could actually trust them and we could give them access to our account based on the trust relationship that we have built with the other identity systems. All right, so two things. One is manage users and their access for manage IAM user and their access in our AWS environment, and second is manage access for federated users who are non-IAM users. And more importantly, IAM is a free service, and with that will only be charged for the use of the resources, not for the IAM username and password that we create. All right, let's now talk about some of the questions in Route 53. One classic question that could be asked in an interview is, what is the difference between latency-based routing and geo-DNS or geo-based DNS routing? Now, the geo-based DNS routing takes routing decisions on the basis of the geographic location of the request. And on the other hand, the latency-based routing utilizes latency measurements between networks and data centers. Now, latency-based routing is used where you want to give your customers the lowest latency as possible. So that's when we would use latency-based routing. And on the other hand, geo-based routing is when we want to direct customers to different websites based on the country they are browsing from. You could have two different or three different websites for the same URL. Take Amazon, the shopping website, for example. When we go to Amazon.com from in the US, it directs us to the US web page where the products are different, the currency is different, right, and the flag and a couple of other advertisements that shows up are different. And when we go to Amazon.com from India, it gets directed to the Amazon.com Indian site, where again the currency, the product, and the advertisements, they're all different, right? So depending on the country they're trying to browse, if you want to direct customers to 2 or 3 different websites, we would use geo-based routing. Another use case of geo-based routing is if we have a compliance that you should handle all the DNS requests, or if you should handle all the requests from a country within the country, then you would do geo-based routing. Now, you wouldn't direct the customer to a server which is in another country, right? You would direct the customer to a server which is very local to them. That's another use case of geo-based routing. And like I said, for latency-based routing, the whole goal or aim is to achieve minimum end-user latency. If you are hired for the architect role and if that requires working a lot on the DNS, then you could be posted with this question: what is the difference between domain and a hosted zone? A domain is actually a collection of data describing a self-contained administrative and technical unit on the internet, right? So for example, Simplilearn.com is actually a domain. On the other hand, hosted zone is actually an container that holds information about how you want to route traffic on the internet to a specific domain. For example, lms.simplilearn.com is an hosted zone, whereas simplilearn.com is an domain. So in other words, in hosted zone, you would see the domain name plus a prefix to it. LMS is a prefix here. FTP is a prefix. Mail.simplilearn.com is a prefix. So that's how you would see a prefix in hosted zones. Another classic question from Route 53 would be, how does Amazon Route 53 provide high availability and low latency? The way Amazon Route 53 provides high availability and low latency is by globally distributed DNS servers. Amazon is a global service and they have DNS services globally. Any customer doing a query from different parts of the world, they get to reach an DNS server which is very local to them, and that's how it provides low latency. Now, this is not true with all the DNS providers. There are DNS providers who are very local to a country, who are very local to a continent. So they generally don't provide low latency service. Right, it's always high latency. It's low latency for local users, but anybody browsing from a different country or a different continent, it's going to be high latency for them. But that's not again true with Amazon. Amazon is a globally distributed DNS provider. It has DNS servers global wide, and like I said, it has optimal locations. It has got global servers, or in other words, it has got servers around the globe, different parts in the globe, and that's how they are able to provide high availability. And because it's not running on just one server but on many servers, they provide high availability and low latency. If the environment that you're going to work on is going to take a lot of configuration backups, environmental backups, then you can expect questions in AWS config. A classic question would be, how does AWS config work along with AWS CloudTrail? AWS CloudTrail actually records user API activity on the account, and any HTTPS access or any sort of access that's made to the cloud environment, that's recorded in the CloudTrail. In other words, any API calls, the time is recorded, the type of call is recorded, and what was the response given, was it a failure, was it successful, they also get recorded in CloudTrail. It's actually a log. It actually records the activity in your cloud environment. On the other hand, config is a point-in-time configuration details of your resources. For example, at a given point, what are all the resources that were present in my environment? What are all the resources, or what are the configuration in those resources at a given point? They get captured in AWS config. Right? So with that information, you can always answer the question, what did my AWS resource look like at a given point in time? That question gets answered when we use AWS config. On the other hand, with CloudTrail, you can answer the question, by looking at the CloudTrail, or with the help of CloudTrail, you can easily answer the question, who made an API call to modify this resource? That's answered by CloudTrail. And with CloudTrail, we can detect if a security group was incorrectly configured and who did that configuration. Let's say there happened to be a downtime, and you want to identify, let's say there happened to be a downtime and you want to identify who made that change in the environment. You can simply look at CloudTrail and find out who made the change. And if you want to look at how the environment looked like before the change, you can always look at AWS config. Can AWS configure or AWS config aggregate data across different AWS accounts? Yes, it can. Now this question is actually to test whether you have used AWS config or not. I know some of the services are very local, is it? Some of these services are availability zone specific, some of them are regional specific, and some of them are global services in Amazon. And though some of these services are region services, you still can do some changes, add some configuration to it and collect regional data in it. For example, S3 is a regional service, but still you can collect logs from all of the regions into an S3 bucket in one particular region. That's possible. And CloudWatch is an regional service, but still you can, with some changes to it, with some adding permissions to it, you can always monitor the CloudWatch that belongs to CloudWatch logs that belongs to other regions. They're not global by default, but you can do some changes and make it global. Similarly, AWS config is a service that's a region-based service, but still you can make it act globally. We can aggregate data across a different region and different accounts in an AWS config and deliver the updates from different accounts to one S3 bucket and can access it from there. AWS config also works or integrates seamlessly with SNS topic. So, anytime there is a change, anytime the new data gets collected, you can always notify yourself or notify a group of people about the new log or the new config or new edit that happened in the environment. Let's look at some of the database questions. Database should be running on reserved instances. So whether you know that fact or not, the interviewer wants to understand how well you know that fact by asking this question. How are reserved instances different from on-demand DB instances? Reserved instances and on-demand instances are exactly the same when it comes to their function, but they only differ based on how they are built. Reserved instances are purchased for 1 year or 3 year reservation, and in return we get a very low per hour pricing because we're paying upfront. It's generally said that reserved instance is 75% cheaper than on-demand instance, and Amazon gives you that benefit because you're committing for 1 year and sometimes you're paying in advance for the whole year. On the other hand, on-demand instances are built on an hourly price. Talking about autoscaling, how will you understand the different types of autoscaling? The interviewer might ask this question: which type of scaling would you recommend for RDS and why? There are two types of scaling, as you would know now, vertical and horizontal. And in vertical scaling, we can vertically scale up the master database with a couple of clicks. Alright, so that's vertical scaling. Vertical scaling is keeping the same node and making it bigger and bigger. If previously it was running on T2 micro, now we would like to run it on M3, 2 times large instance. Previously it had 1 virtual CPU, 1 gigabit. Now it's going to have 8 virtual CPU and 30 gigabit of RAM. So that's vertical scaling. On the other hand, horizontal scaling is adding more nodes to it. Previously it was running on 1 VM. Now it's going to run on 2, 3, 10 VMs. Right, that's horizontal scaling. So database can only be scaled vertically, and there are 18 different types of instances we can resize our RDS to. Right, so this is true for RDS MySQL, Postgres SQL, MariaDB, Oracle, Microsoft SQL servers. There are 18 type of instances we can vertically scale up to. On the other hand, horizontal scaling are good for replicas. So they are read-only replicas. We're not going to touch the master database. We're not going to touch the primary database, but I can do horizontal scaling only with Amazon Aurora, and I can add additional read replicas. I can add up to 15 read replicas for Amazon Aurora and up to 5 read replicas for RDS MySQL, Postgres SQL, and MariaDB RDS instances. And when we add replica, we are horizontally scaling, adding more nodes, right? Read-only nodes. So that's horizontal scaling. So how do you really decide between vertical and horizontal scaling? If you're looking to increase the storage and the processing capacity, we'll have to do a vertical scaling. If you're looking at increasing the performance or of the read-heavy database, we need to be looking for horizontal scaling, or we need to be implementing horizontal scaling in our environment. Still talking about database, this is another good question you can expect in the interview. What is the maintenance window in Amazon RDS? Will your DB instance be available during the maintenance event? Alright, so this is really to test how well you have understood the SLA, how well you have understood the Amazon RDS, the failover mechanism of Amazon RDS, stuff like that. So RDS maintenance window, it lets you decide when a DB instance modification, a database engine upgrades, or software patching has to occur. And you actually get to decide, should it happen at 12 in the night, or should it happen at afternoon? Should it happen early in the morning? Should it happen in the evening? You actually get to decide. And automatic scheduling by Amazon is done only for patches that are security and durability related. Sometimes Amazon takes down and does automatic scheduling if there is a need for a patch update that deals with security and durability. And by default, the maintenance window is for 30 minutes. And the important point is the DB instance will be available during that event, because you're going to have primary and secondary, right? So when that upgrade happens, Amazon would shift the connection to the secondary, do the upgrade, and then switch back to the primary. Another classic question would be, what are the consistency models in DynamoDB? In DynamoDB, there is eventual consistency read. This eventual consistency model, it actually maximizes your read throughput. And the best part with eventual consistency is all copies of data reach consistency within a second. And sometimes when you write and when you're trying to read immediately, chances that you would still be reading the old data. That's eventual consistency. On the other hand, there is another consistency model called the strong consistency, or strongly consistent read, where there is going to be a delay in writing the data, making sure the data is written in all places, but it guarantees one thing, that is, once you have done a write and then you're trying to do a read, it's going to make sure that it's going to show you the updated data, not the old data. You can be guaranteed of it that it is going to show the updated data and not the old data. That's strongly consistent. Still talking about database, talking about NoSQL, DynamoDB or NoSQL database, which is DynamoDB in Amazon. You could be asked this question: what kind of query functionality does DynamoDB support? DynamoDB supports get and put operation. DynamoDB supports, or DynamoDB provides flexible querying by letting you query on non-primary key attributes using global secondary index and local secondary indexes. A primary key can be either a single attribute partition key or a composite partition sort key. In other words, a DynamoDB indexes a composite partition sort key as a partition key element and a sort key element. And by holding the partition key, when doing a search or when doing a query, by holding the partition key element constant, we can search across the sort key element to retrieve the other items in that table. And the composite partition sort key should be a combination of user ID partition and a timestamp. So that's what the composite partition sort key is made of. Let's look at some of the multiple choice questions. Sometimes some companies would have a written test or an MCQ type online test before they call you for the first level or before they call you for the second level. So these are some classical questions that companies ask in their multiple choice online questions. Let's look at this question. As a developer, using this pay-per-use service, you can send, store, and receive messages between software components. Which of the following is being referred here? Let's look at it. Right, we have AWS Step Functions, Amazon MQ, Amazon Simple Queue Service, Amazon Simple Notification Service. Let's read the question again. As a developer, using this pay-per-use service, so the service that we are looking for is a pay-per-use service, you can send, store, and retrieve messages between two software components, kind of like a queue there. So what would be the right answer? It would be Amazon Simple Queue Service. Now, Amazon Simple Queue Service is the one that's used to decouple the environment. It breaks the tight coupling and then it introduces decoupling in that environment by providing a queue or by inserting a queue between two software components. Let's look at this other question. If you would like to host a real-time audio and video conferencing application on AWS, right? It's an audio and video conferencing application on AWS. This service provides you with a secure and easy to use application. What is this service? Let's look at the options. They are Amazon Chime, Amazon Workspace, Amazon MQ, Amazon AppStream. You might tend to look at Amazon AppStream because it's real-time and a video conference, but it's actually for a different purpose. It's actually Amazon Chime that lets you create chat and create a chat board and then collaborate with the security of the AWS services. So it lets you do the audio, it lets you do the video conference, all supported by AWS security features. It's actually Amazon Chime. Let's look at this question. As your company's AWS solution architect, you are in charge of designing thousands of individual jobs which are similar. Which of the following service best serves your requirement? AWS EC2 Autoscaling, AWS Snowball, AWS Fargate, AWS Batch. Let's read the question again. As your company's AWS solution architect, you are in charge of designing thousands of individual jobs which are similar. It looks like it's batch service. Let's look at the other options as well. AWS Snowball is actually an storage transport service. EC2 Autoscaling is introducing scalability and elasticity in the environment, and AWS Fargate is container services. AWS Batch is the one is being referred here that actually runs thousands of individual jobs which are similar. AWS Batch is the right answer. Right, let's look at the other one. You are a machine learning engineer and you're looking for a service that helps you build and train machine learning models in AWS. Which among the following are we referring to? So we have Amazon SageMaker, AWS Deep Lens, Amazon Comprehend, AWS Device Farm. Let's read the question again. You are a machine learning engineer and you're looking for a service that helps you build and train machine learning models in AWS. Which among the following are referred here? The answer is SageMaker. It provides every developer and data scientists with the ability to build, train, and deploy machine learning models quickly. That's what SageMaker does. Now, for you to be familiar with the products, I would recommend you to simply go through the product description. There's one page available on Amazon that explains all the products, quick, neat, and simple. That really helps you to be very familiar with what the product is all about and what it is capable of. Is it a DB service? Is it a machine learning service? Or is it a monitoring service? Is it a developer service? Stuff like that. So get that information, get that details before you attend an interview, and that should really help to answer or face such questions with great confidence. So the answer is Amazon SageMaker, because that's the one that provides developers and data scientists the ability to build, train, and deploy machine learning models quickly as possible. All right, let's look at this one. Let's say that you are working for your company's ID team and you are designated to adjust the capacity of the AWS resource based on the incoming application and network traffic. How do you do it? So what's the service that actually helps us to adjust the capacity of the AWS resource based on the incoming application? Let's look at it. Amazon VPC, Amazon IAM, Amazon Inspector, Amazon Elastic Load Balancing. Amazon VPC is a networking service. Amazon IAM is an username password authentication. Amazon Inspector is a service that actually does a security audit in our environment. And Amazon Elastic Load Balancer is a service that helps in scalability. That's in one way, indirectly that helps in increasing the availability of the application, right? And monitoring how much requests are coming in through the Elastic Load Balancer, we can actually adjust the environment that's running behind it. So the answer is going to be Amazon Elastic Load Balancer. All right, let's look at this question. This cross-platform video game development engine that supports PC, Xbox, PlayStation, iOS, and Android platforms allows developers to build and host their games on Amazon's servers. So we have Amazon GameLift, Amazon Greengrass, Amazon Lumberyard, Amazon Sumerian. Let's read the question again. This cross-platform video game development engine that supports PC, Xbox, PlayStation, iOS, and Android platforms allows developers to build and host their games on Amazon servers. The answer is Amazon Lumberyard. This Lumberyard is an free AAA gaming engine deeply integrated with AWS and Twitch with full source. This Lumberyard provides a growing set of tools that helps you create an highest game quality applications, and they connect to a lot of games and vast compute and storage in the cloud. So it's that service they are referring to. Let's look at this question. You are the project manager of your company's cloud architect team. You are required to visualize, understand, and manage your AWS cost and usage over time. Which of the following service will be the best fit for this? We have AWS Budgets, we have AWS Cost Explorer, we have Amazon Workmail, we have Amazon Connect. And the answer is going to be Cost Explorer. Now, Cost Explorer is an option in the Amazon console that helps you to visualize and understand and even manage the AWS cost over time. Who's spending more? Who's spending less? And what is the trend? What is the projected cost for the coming month? All these can be visualized in AWS Cost Explorer. Let's look at this question. You are a chief cloud architect at your company, and how can you automatically monitor and adjust computer resources to ensure maximum performance and efficiency of all scalable resources? So we have a CloudFormation as a service, we have AWS Aurora as a solution, we have AWS Autoscaling, and Amazon API Gateway. Let's read the question again. You're the chief cloud architect at your company. How can you automatically monitor and adjust computer resources? How can you automatically monitor and adjust computer resources to ensure maximum performance and efficiency of all scalable resources? This is an easy question to answer. The answer is Autoscaling. Right, that's a basic service and solution architect course, is it? Autoscaling is the service that helps us to easily adjust, monitor, and ensure the maximum performance and efficiency of all scalable resources. It does that by automatically scaling the environment to handle the inputs. Let's look at this question. question. As a database administrator, you will use a service that is used to set up and manage databases such as MySQL, MariaDB, and PostgreSQL. Which service are we referring to? Amazon Aurora, Amazon Elasticache, AWS RDS, AWS Database Migration Service. Amazon Aurora is Amazon's flavor of the RDS service, and Elasticache is the caching service provided by Amazon. They are not full-fledged database. And database migration service, just like the name says, it helps to migrate the database from on-premises to the cloud and from one database flavor to another database flavor. Amazon RDS is the service, is the console, is the service, is the umbrella service that helps us to set up, manage databases like MySQL, MariaDB, and PostgreSQL. It's Amazon RDS. Let's look at this last question. A part of your marketing work requires you to push messages onto Google, Facebook, Windows, and Apple through APIs or AWS Management Console. You will use the following service. So the options are AWS CloudTrail, AWS Config, Amazon Chime, AWS Simple Notification Service. All right, it says a part of your marketing work requires you to push messages. It's dealing with pushing messages to Google, Facebook, Windows, and Apple through APIs or AWS Management Console. You will use the following service. It's Simple Notification Service. Simple Notification Service is a message pushing service. Right? SQS is pulling. Similarly, SNS is pushing. Right? Here it talks about a pushing system that pushes messages to Google, Facebook, Windows, and Apple through API, and it's going to be a simple notification system or a simple notification service.
Hello everyone, this is Samuel, and I'm very excited that you're watching this video, and I would like to welcome you to this Azure interview preparation session. Knowing Azure is one thing, having worked on Azure is another thing, and being able to answer interview questions in Azure is a totally different thing. Although one helps the other, it's still different skills. And our aim through this video is to prepare you with common product and scenario-based interview questions. So why wait? Let's get started. A common cloud interview question is, what's the difference between SaaS, PaaS, and IaaS? We all know that a software as a service is thin client model of software provisioning, where client in this case usually is simply a web browser providing the point of access to softwares running on the servers. Now, SaaS is the most familiar form of cloud service for customers. SaaS moves the task of managing software and its deployment to third-party services, meaning the vendor actually gets to manage all that. So SaaS is software as a service involving applications being consumed and used by organizations. So it's generally using an application, and usually organizations pay for their use of this particular application. Now, some examples of SaaS would include Office 365. Salesforce is another very good example of SaaS, and a lot of Google apps and storage solutions like Box and Dropbox are a very good example of software as a service. Talking about platform as a service or PaaS, it actually functions at the lower level than SaaS. Now, typically it provides a platform on which software can be developed and deployed. Now, here we develop the software, we deploy the software. Now, PaaS actually provides an abstract of much of the work dealing with servers and giving client an environment in which the operating system and the server software and the hardwares and the network are managed and taken care. In other words, with a platform as a service, all the things that I've mentioned, like the servers, the server software, the hardware, everything is managed by the provider, and we can focus on business side of the scalability, and we can focus on application development of our product or the service. So in short, platform as a service is a service that enables developers to build and work with applications without even having to worry about the infrastructure or management of the underlying hosting environments. And some examples of PaaS in Azure is SQL and Azure Storage. Talking about infrastructure as a service, IaaS, now this is moving down the stack even further. Now we get to the fundamental building block of the cloud service, which is infrastructure as a service, IaaS. Now IaaS is fully of highly automated, scalable computer resources. IaaS is full of storage. IaaS is full of the network capability. That's what IaaS is. Now, IaaS clients have direct access to the servers and storage, just as they would to do traditional servers. But in this case, it's going to be in the cloud. In this case, it's going to be more scalable. So IaaS is very similar to what you would do in your on-premises physical data center. But when we talk about IaaS, we get to do everything, but it's stored in the cloud. So if we need to build a definition around IaaS or infrastructure as a service provides users with components. It provides components. It does not give us a built environment. It simply provides a component such as operating system, networking capabilities, and a lot more. Now, this is a paid for based on the usage and can be used to host applications. In other words, this is pay as you go type. The more you use, the more you pay. The less you use, the less you pay. And some of the examples of IaaS in Azure is virtual machine. That's a great example for IaaS, and VNets for networking. That's another good example for IaaS in Azure. Another common question in Azure interview is, what are the instance types offered by Azure? The main intention of this question is, how well have you understood the different offerings in Azure, and how well are you trained to pick the right offering for the right service? Now, one size does not fit all, and there are a lot of services in Azure that under the carpet it does the same thing, but depending on how different your requirement is, we'll have to pick the appropriate service. So this question, what are the different instance types offered by Azure, it's to test how well have you used the product and services available in Azure, and how well have you applied them for the given requirement. You shouldn't be provisioning more, you shouldn't be provisioning less at the same time. So it's kind of matching the right service to the right requirement. So what are the instance types offered by Azure? As you see in the list, we have general purpose, compute optimized, memory optimized, storage optimized, GPU virtual machines, and high performance compute virtual machines. Now, answering just the names won't be enough in an interview. You'll have to go further and explain why and in what scenario you would use general purpose, and what are the use cases, what type of servers is a good fit for a general purpose, and what type is a good fit for compute optimized, so on and so forth. And that's exactly what we're going to do now. So the general purpose VMs, they provide a balanced CPU to memory ratio, and it's very good for testing, very good for a development environment, very good for small and medium databases, and also for low to medium traffic web servers. And some of the use cases are, like we said, test servers, low traffic web servers, small to medium databases, some enterprise grade applications. It's also good for relational database. It's also good for servers used for in-memory caching. It's also good for some small analytic database, very good for microservices. And if you're trying to build a proof of concept for an idea that you just have or just parked, this is another good server for doing proof of concepts, because you're not going to send actual traffic to it. I just want to show that your idea works. So general purpose server is a very good use case for those scenarios. And the largest instance size we can get in general purpose is standard D64 V3. Which comes with 256 gigabit of memory and 1600 gigabit of SSD temporary storage. On the other hand, compute optimized VMs have a high CPU to memory ratio and are very good for medium traffic web servers, very good for batch processing servers, very good for application servers. Now, because it's compute optimized and compute means CPU, it's an excellent choice for workloads that demand faster CPU, but does not need as much memory or temporary storage virtual CPU. Some of the workloads that run very well on compute optimized are analytic workloads, gaming servers require more CPU, they run really well. Batch processing are some of the applications that can be placed in compute optimized, and by doing that we get the actual benefit of the compute optimized instance. And the largest instance size, or the largest instance size type, is standard F72's V2, and here we get 144 gigabit of memory and 576 gigabit of SSD temporary storage in compute optimized VMs. In the same lines, memory optimized VM They offer high memory to CPU ratio, and that are great for databases. Databases require more memory, so it's a great fit for database, and it's a great fit for medium to large scale caches, applications that require in-memory analytics. So this memory optimized, memory is more, so it's very good for in-memory analytics applications. And the largest instance size we get here is standard M128M, and look at the gigabit of memory. It's 3892 gigabit of memory, and look at the temporary storage. It's 1400 gigabit of temporary storage. On the same lines, storage optimized. Now I guess I don't have to explain to you what storage optimized is used for. You might have easily guessed looking at the flow. Yes, storage optimized VM offer high disk throughput and IO and are very ideal for big data, SQL, NoSQL databases, data warehousing servers, large transactional databases, and a lot more. And some of the examples of the applications that can be launched on storage optimized are Cassandra, MongoDB, Cloudera, Redis. These are some familiar applications that can get benefited when we run them on storage optimized. And one difference between storage optimized and the other servers are they are generally optimized to use the local disk on the node attached directly to the VM rather than using an durable disk, which is actually a remote disk space. Now what does this allow? This allows for greater input outputs per second, or throughput for the workload. So that's what we get. A greater throughput, a greater input outputs per second is what we get when we use storage optimized. And the largest instance size available in storage optimized is standard L32S, and the memory is 256 gigabit. And look at the temporary storage. It's 5630 gigabit of temporary storage. GPU type VMs, easy to guess. GPU optimized VMs are specialized virtual machines available with multiple GPUs attached to them. Now these sizes are designed for, or these VMs are designed for compute intensive, graphic intensive visualization workloads that require a lot of graphical processing unit attached to it. So in short, these are virtual machines that specialize in heavy graphic rendering and video editing. It also helps with model training and interferencing with the standard ND24RS, which has 448 gigabit of memory and 2948 gigabit of temporary storage. And the last but not the least, but the best, is high performance compute, or Azure H series virtual machines. Now they are the latest in high performance computing VMs and are aimed to handle workloads like batch processing, analytic, molecular modeling, and fluid dynamics. A lot of complicated applications in this VM. And this is the fastest and powerful CPU virtual machine with optional high throughput interfaces. And the largest instance size that's available is standard L32S, which comes with 224 gigabit of memory and 2000 gigabit of SSD temporary storage. And a third common question is, what are the deployment environments offered by Azure? There are two main deployment environments. One is the staging environment and the other one is the production environment. Now in staging environment, let's talk about staging first. So when you're deploying your web app or web app on Linux, you can deploy them to a separate slot instead of the default production slot when running them in standard premium or isolated app service plan tiers. Now the deployment slots are actually live app with their own host name, and at a later point the staging environment can be swapped with the production environment. So why do we need a staging environment? What are the benefit of it? So the benefit of deploying our application to a non-production or staging environment, it provides a platform to validate changes to our application before it can be made live in the production environment. And in the staging environment, the app can be identified using the Azure's global unique identifier, also called as the GUID URL. And it's very similar to the production URL, except that it has a custom name in front of it that identifies it as the staging environment.
And for production environment, this is the live production environment that's serving customers' request, that's serving the customer content. Now, it can be slightly different from the staging environment in a way that the URL that's used to identify the production environment, that's more of an DNS friendly name, like the name of the actual service.cloudapp.net. That way it differs. In case of staging environment, you have an custom name right before it, so the custom name and then the cloudapp.net, but in this case you get the direct service name as the name of the URL. So this is live production environment which receives and handles and serves customer traffic. Another commonly asked question in Azure is what are the advantages of scaling in Azure? The actual thought behind the question is to see how much have you understood scaling, how much have you seen and how much have you applied the scaling effect in the production environment and have received benefits in return. So let's talk about it. Advantages of scaling in Azure. Some of the advantages are we get the maximum application performance. Now, autoscaling is a built-in feature for the cloud services, be it AWS Azure, Google, and a couple of other cloud service providers. It's a built-in feature for a cloud service. A cloud service should be auto-scalable. And that includes mobile services, virtual machines, and when we run our applications on mobile services or virtual machines, the website actually gets the best performance during the change in the demand. Again, different applications might require different performance needs. For example, for some apps, the performance is measured based on memory. And another good example is the fluctuating demand. For example, you could have a web app that handles millions of requests during the day and literally nothing at the night. And autoscaling this environment, any of these environment will automatically scale or fatten your environment so to receive all the incoming traffic, and during lean period it actually gets slimmer and slimmer so to help you with the cost. So it actually maximizes the performance. That's what autoscaling does. And like we said, autoscaling scales up and scales down based on demand. It not only scales up but also scales down so to help you with the cost. And if you know the particular pattern in which the application is going to receive traffic, then we can very well go ahead and schedule scaling to our application or schedule scaling that infrastructure based on time. If we already know that Monday to Friday, that's the traffic that I would get, and it's a constant one. It's not a public facing, but it's an internal application. So I know all the 500 users or the 1,000 or the 5,000 users who will be using it. So at any given point, it's just 5,000 users. It's not going to go beyond that. And during Saturday and Sunday, literally nobody's going to be in office. So no load at all. So in that case, I pretty much know how the pattern is going to be. I can go for scheduled scaling if I know the pattern. And auto scaling, like I said, not only helps with keeping the application highly available, it also helps with the cost effectiveness of our infrastructure. So anytime there's a VM or a group of VMs running on less CPU, autoscaling is going to actually get the environment slimmer and slimmer, so we're not unnecessarily running any resources and paying for it. If you're being interviewed for the infra side in Azure, this is another common question that gets asked. How are Windows Active Directory and Azure Active Directory different? Let's talk about the Windows Active Directory first. The non-cloud Windows Active Directory the service was released along with Windows 2000 Server Edition, and this Active Directory is essentially a database that helps organizations to organize the users, organize the computers, and a lot more. It provides authentication and authorization to the applications. Not only to the applications but also to file servers, to printers, and a lot of other on-premises resources. That's what the basic non-cloud Active Directory does. On the other hand, the Azure Active Directory is not designed to manage web-based services. The Azure Active Directory, on the other hand, was designed to support web-based services that use REST API interfaces for Office 365, Salesforce.com, etc. Unlike the plain Active Directory, this uses a completely different protocol. So protocol wise it's different, and the services that it supports is quite different. Now besides that, it also has a couple of other differences as well. and let's look at them. So the actual Active Directory or the Windows Actual Directory is a directory service that facilitates working with interconnected, complex and different network resources in a very unified manner. On the other hand, Azure Active Directory is Microsoft's multi-tenant, cloud-based directory and identity management service. And the Windows Active Directory has 5 layers to store data, to store user details, and to issue the management certifications. On the other hand, Azure Active Directory integrates or compresses the 5 layers into just 2 layers. Here, Windows Active Directory works with on-premises servers like applications, file servers and printers, etc. On the other hand, Azure Active Directory, it works on web-based services that use RESTful interfaces. If you're being hired for the development environment or for the cloud DevOps support environment, or even for the production support environment, you might find yourself being asked this question: what are the types of queues offered by Azure? Now, Azure supports 2 types of queue mechanisms, the storage queue and the service bus queue. Let's talk about storage queue first. Now, the storage queue, which are part of Azure storage infrastructure, it provides a simple REST-based interface, simple REST-based get, put and peek interface. It provides reliable, persistent messaging within and between the services. It follows the pub-sub model or a pub-sub messaging infrastructure, and it's best suited for users that need to store more than 80 gigabyte of messages in the queue. It can provide logs for all the transactions executed against the user's queue. So that's what we get with storage queue. And on the other hand, service bus queue, the service bus queues are built on top of broader messaging infrastructure, and they are designed to integrate applications and applications component that can span multiple communication protocols. So that way it differs. So this is good for applications and components that may span multiple communication protocols and even totally different network environments. So in short, these service buses or the service bus queues in Azure are part of Azure's messaging infrastructure, and they integrate applications or application components that can actually span multiple different protocols and multiple different network environments. It also provides an first in first out style for delivery, and the user's queue size has to remain under 80 gigabit. Another familiar question is, what are the advantages of Azure Resource Manager? Now, the Resource Manager helps us to manage the usage of the application resources. This question is actually to test how well have you tested, how well have you used Resource Manager and have gotten the benefit of it. This question actually tests how easy it has become after the introduction of Resource Manager compared to when doing deployments or when provisioning resources without the Resource Manager. So let's get into the answers for the question. What are the advantages of Azure Resource Manager? In short, Resource Manager is called ARM. So the ARM helps deploy, manage and monitor all the resources for an application, a solution or a group. So all the interconnected application, all the interconnected services can be monitored as group using Resource Manager, and users can be granted to access to resources that they require within a Resource Manager. So in an account, I can have like 10 different resources created by a Resource Manager or a resource group created by Resource Managers, and I can deny connection to those services or only to those services based on whether the user should be accessing one and not accessing the other. So that way it becomes easy to give access to a group of application. It helps in getting billing details for the group of resources. Now, which group is using more, which group is using less, and which group has contributed more to this month's bill, stuff like that. So those details can be obtained using Azure Resource Manager. And provisioning resources is made much easier with the help of this Resource Manager. Another question is, how has integrating hybrid cloud been useful for Azure? Well, with the use of hybrid cloud, we get the best of both the worlds. So what's hybrid cloud? It's nothing but combining the public cloud and the private cloud and allowing data and applications to be shared between them. So whenever the compute or the processing demand fluctuates, hybrid cloud computing gives businesses the ability to seamlessly scale their on-premises infrastructure in the public cloud and handle any kind of overflow in the requirement or overflow in handling the application. So it really helps. It helps it boosts the productivity of our on-premises application. So with the hybrid cloud, we get a greater efficiency with combination of Azure services, DevOps processes and tools for the application running in on-premises. And by having a hybrid cloud environment, users can take advantage of a constantly updated Azure service and other AWS marketplace applications for their on-premises environment. And the other benefit is with hybrid cloud environment, we can simply deploy applications regardless of its locations. In case of on-premises, we'll have to worry about the location, but when we expand our on-premises environment in the cloud, and we can pick any of the locations and simply deploy it in them. And this enables the applications to be created at a greater speed. What's federating in Azure SQL? Now this question is very specific about SQL. How can we scale the SQL database? Now this is a very good question, or a valid question, or an important question in the interview, because many customers or companies have not been able to meet the user demand because they could not scale out the databases. The theory of scaling out or adding servers to accommodate the increased workloads and traffic is not hard to understand, but the implications can be very complicated. The implications can be very expensive. We're well aware of scaling the web servers, that's very common, but how do we scale the database? So Microsoft provides the tools and technologies so we can scale out the database in the cloud, and that's what is called SQL or federation in Azure SQL. So the way we scale out the SQL database is by sharding the database. So sharding actually enables users to take advantages of the resources in the cloud. Not only that, it allows users to have their own database or a shared database amongst each other. Because we're creating a highly available database, because we're having shards in a database, it actually reduces the possibility of a single point of failure for our database. And more importantly, because we're sharding, because we're using federation in Azure SQL, it provides an cost-effective scaling of our databases by using cloud resources, or by using billing only for the cloud resources that we have used. So no pre-provisioning, no over-provisioning. It provisions the right amount and we pay the right amount. Let's talk about this one. What are the different types of storage offered by Azure? Now the different types of storage offered by Azure are, as you already know, and as you can see, they are Azure blob storages, table storages, file storage, and queue storage. So let's expand one after the other. Now blob storage are nothing but a massive scalable object storage, and that's very good for storing text and binary data. And Azure blob storage is Microsoft's object storage solution for the cloud. Now, blob storage is optimized for storing massive amount of unstructured data that can be in form of text or in form of binary data. So in short, blob storage enables users to store unstructured data, and those data can be in the format of pictures, music, video files, and a lot more. And it stores them along with their metadata. And another advantage or another feature benefit that we get from blob storage is when an object is changed, it is verified to ensure it is of the latest version, number one. And number two, it provides maximum flexibility to optimize the user's storage needs. And this unstructured data is available to customers through an URL or an REST-based object storage. So they are the benefits that come along with the blob storage. Table storage, on the other hand, is a NoSQL store for schemaless storage of secured data. Now this Azure Table Storage is a service that stores structured NoSQL data in the cloud. And because this table is schemaless, it's very easy to save your data. It's very easy to adapt your data as the need for your application grows. And this table storage is very fast and cost effective for many type of applications. So some of the type of data that we can store is table storage is good for flexible databases like user data for web applications, address book storage, device information storage, and if you want to store metadata, this is a very good use case to store them in Azure Table Storage. Azure Files is another storage. Here it's a managed file share for cloud or on-premises deployment. So file storage provides file sharing capabilities accessible by the server messaging block protocol, and this can be accessed from the cloud, and this can be accessed from on-premises as well. Here in file storage, the data is protected by SMB 3.0 and HTTPS protocols. And the more important thing is Azure takes care of managing hardware and the operating system deployments for Azure file storage. So this additional file storage can be used when we want to burst the storage capacity in on-premises. So on-premises, the primary, and cloud is the secondary or the extended on-premises storage. So it actually improves the on-premises performance and capabilities for our on-premises data center. And then we have queues, Azure Queues. It's a messaging store for reliable messaging between the application components. We spoke a little about this in the previous question. So the Azure Queue Storage is a service for storing a large amount of messages that can be accessed from anywhere in the world via HTTP or HTTPS protocol. In here, a single message can be up to 64 kilobits in size, and in a queue we can have millions of messages, and the limit can actually go up if we have not reached the limit of the storage account. So it's millions and millions of requests that can be stored in the storage queue or the queue storage. So the queue storage, in short, provides message queuing for large workloads, and it enables users to build flexible applications and separate the functions one from another, so one failing doesn't affect the other application which is running healthy. And this queue storage, it ensures the application is scalable and less prone to individual component failures because they are decoupled, separate now. It also helps in monitoring the queue, which ensures the customer's demands are met. So queue is a great place to monitor, or a great component to monitor, so we understand how much peak have we reached for a particular application, service, or a container.
What is text analysis API in Azure Machine Learning? Now, text analysis is actually an cloud-based analytics API, and it provides an advanced natural language processing over the raw text. And it has got four main functions, like the sentiment analysis and the key phrase analysis, language deduction, and a few other things. Now, what do you mean by sentiment analysis? Now, sentiment analysis is from the logs, from the comments, from the text comments that we receive, do an analysis and find out whether that's a positive or a negative statement. Now, if it is the API returns an sentiment score between 0 and 1, and 1 is positive and 0 is negative. And then in text analysis, we have a key phrase extraction, which is it will automatically extract the key phrase to quickly identify the main points in that key phrase. For example, if you're analyzing a text which says the food was delicious and there were wonderful stuff, then the API returns the main talking points of that phrase, like food is the main talking point, and wonderful stuffs, that was a main talking point. So that's another feature that this text analysis has. And then we have language deduction in text analysis, right? Irrespective of what you paste, it can try to gauge and try to align it to the 120 or up to 120 languages that it supports. So I can simply take text from the internet and I can paste it, and text analysis software is going to identify the language and then can run phrase and sentiment analysis on those texts. Right. So in short, text analysis is an API, a set of web services that can be used for text analysis. It can be used to analyze unstructured statement, sentiment analysis, key phrase extraction, and a lot more. And the results are generally between 0 and 1 being positive and 0 being the negative sentiment. There is no much training, or in other words, this is not as complicated as a couple of other text analysis softwares are available in the market. We can simply paste, we can simply upload the text, and we can call the service and it runs a sentiment analysis on it all by itself. Let's look at this question. What are the advantages of Azure Queue Storage? If you're going to work in a development environment, if you're going to work in an environment that embraces DevOps, this could be a question. What are the advantages of Azure Queue Storage? Now, Azure Queue Storage is built to flexibly operate the applications and separate the functions between the applications that run large workloads. So when we design applications for scale, these applications can be decoupled so that they can scale independently. And thing happening on an application is not dependent on another application, and anything happens to a section of the application will not affect the other application because they are now decoupled and connected through the queue storage. So the queue storage gives us asynchronous message queuing for communication between the applications, irrespective of whether they are running in the cloud or whether they are running in desktop or whether they are running on premises or on mobile devices. So in short, this queue storage enables message queuing for large workloads in a simple and cost-effective and a durable manner. Talking about the advantages is it provides rich client libraries for Java, Android, C++, PHP, Ruby, and a lot other services getting added during every new release from Azure. And the main advantage again is it enables users to build flexible apps and separate the functions for bigger or greater durability. Again, introduction of queues into our application, it ensures our users' applications are scalable and less prone to individual component failures, meaning one component failing is not going to take the whole application down. Right? If one component fails, it's just that component that fails. The rest are healthy and the rest are going to function. It also helps us to monitor the queues and ensure the servers aren't overwhelmed by sudden traffic bursts. So how much do I have in the queue kind of determines the traffic for my application. And if the queue is more, I can always go and auto scale my environment, and the queue is less, I can always go and shrink or make my environment thinner so it can save cost. And anytime there is more data in the queue, I can auto scale, monitor the metric and do auto scaling based on that metric. So the environment knows that there are more data coming in. I need to expand myself to handle that much amount of data. This is a very common question. What are the two kinds of Azure Web Service roles? Now, a service role is a set of managed and load balanced virtual machines that work to perform some task. And based on what it's going to run on top of it, is it going to run a web service or is it going to run a worker service, defines what kind of roles that gets attached or that goes on these virtual machines. So we have two types, web role and worker roles. The web role is a cloud service role that's configured to run web applications developed on programming languages, technologies. And majorly they support IIS, Internet Information Service, and they support ASP.NET, PHP, Windows Communication Foundation, and so on. So that's web roles. And these web roles, it automatically deploys and hosts application through the user's IIS, Internet Information Service. On the other hand, worker roles are roles that runs applications and service level tasks which generally do not require IIS. So IIS is actually the differentiating factor. So in worker roles, IIS is not installed by default. The worker roles are mainly used to perform supporting background process along with web roles and do tasks automatically compressing or uploading the images, running scripts, and or doing some changes in the database, getting new messages from the queue and processing, and a lot more. The work, the applications, or the work that does not require IIS. That's what this worker role does. Again, the main difference between the web role and the worker role is that the web role automatically deploys and hosts your application through IIS, whereas the worker role does not use IIS and runs our application as standalone. This is another classic question. What is Azure Service Fabric? So Azure Service Fabric is actually a distributed system platform that makes it easy to pack, deploy, and manage scalable and reliable microservices and containers. Now, Service Fabric also addresses some of the significant challenges in developing and managing cloud-native applications. And the problem that it addresses and fixes is, now developers and administrators can avoid complex infrastructure problems and focus on implementing mission-critical and demanding workloads that can be scaled and that can be managed through the console or from the single place. In short, Service Fabric provides a platform that makes the process of developing microservices and managing application lifecycle a lot easier. And the advantages of Service Fabric is that now we can produce application with faster time to market, because all the worry about the infrastructure is taken away from us. We don't have to design an infrastructure. All that we need to worry about is simply the application and the application lifecycle. Again, the advantage is it supports Windows, it supports Linux. Not only that, it supports servers on premises and in the cloud. With Service Fabric, we can scale up our environment to even 1,000 machines in just a single command. Or if there is an immediate need for 1,000 machines, I can immediately scale them up to 1,000 machines. That's possible with Service Fabric. Now let's look at this question. You can expect this question if the customer is running hybrid environment, meaning having some of the applications in on-premises and running some of the applications from the cloud. And for some reason, when classifying the application that goes to the cloud and that stays on-premises, they have decided to keep the database in-house. So in that environment, a lot of customers do that. So in that environment, this is a classic and a scenario-based question. A client wants the front end of their application to be hosted on Azure in the cloud and wants the database to be hosted in on-premises for security reasons or to have full control on their databases. How do we go about suggesting a solution for this customer? The ideal solution in this scenario is to use the VNet-based point-to-site VPN solution. So all the front-end applications will be in the cloud and they'll be hosted in a VNet, and from the VNet they'll be connecting to the database through an point-to-site VPN. So the traffic and the writings and the reads are not coming through the internet, but through a point-to-site VPN link that's connecting the Azure VNet and the on-premises environment. And this model or this approach or this solution is best suited for scenarios where there are only a limited number of resources that needs to be connected between on-premises and the cloud. This is a very common question. What's Azure Traffic Manager? Of course, we no more running applications on a single server. We no more running applications on or from a single environment. Right? The same application is being run from multiple environments within Azure, and it can be running from Azure and on-premise as well. So multiple environments between Azure and on-premises. And a lot of customers have such environment. And if you're facing an interview with such customer, this could be an ideal question. What is Azure Traffic Manager? Now, the Azure Traffic Manager is a DNS-based traffic load balancer that actually enables us to distribute traffic between services across Azure global regions. And by doing this, it provides a good availability and a good responsiveness to the application. And this traffic manager, it uses DNS to direct client requests to the most appropriate service endpoint based on the traffic routing logic and the health of the endpoints that it maintains. So in short, this traffic manager is a load balancer that enables users to provide high availability and responsiveness by distributing traffic in an optimal manner across the Azure when we run the same application in different regions. So some of the advantages or some of the use cases of using Azure Traffic Manager is it provides multiple automatic failover options. It also helps with reduced downtime. It also helps with the distribution of user traffic across multiple locations. So one location is not overloaded. And then it helps with users knowing from where our customers are getting connected from. That's another big use case with Azure Traffic Manager. Let's look at this question. Right, this is an ideal question. Now there are a group of servers connected together within an virtual network, and now we need to move them or create a separation between them. How do you go about achieving it? So the question goes like this. You need to isolate network traffic among VMs in a subnet, which is part of a virtual network with little downtime and impact on the users. So that's the given scenario. And the best way we can do it is create a new virtual network and move all the VMs in that subnet to the new virtual network. Now, this feature is not possible with a lot of other cloud service providers like AWS and a lot of other providers. Now, in those environments, we might need to shut down, we might need to stop the VM, create a new VM based on the image, and it's an hefty process. But here in Azure, I can simply move the VMs from one subnet to another virtual network without needing for any additional security like the network security group. I can simply isolate them if I need to by creating a simple new virtual network and moving the servers to the new virtual network. Look at this one. This is another common question. With respect to Azure, what is public, private, and hybrid cloud? So this is really to test how well have you understood the different cloud offerings in the market, public, private, and hybrid, or at least the three basic offerings in the market: public, private, and hybrid cloud. Now, the public cloud is the most common way of deploying cloud computing applications, and it has resources like servers, storage, and are owned and operated by third-party cloud service providers like Microsoft Azure. Microsoft Azure is a very good example of public cloud. So here, every component that the user is using is running only on Azure. That's public cloud. Right, let me talk to you about some of the advantages of public cloud. Some of the advantages is low cost, because there's no need to purchase hardware or software, and we pay only for the services that we use in public cloud. And there is literally no maintenance, because the service provider maintains the environment for us. And with public cloud, we have nearly unlimited scalability, meaning we can get resources on demand and can meet our business requirements on demand. And the public clouds are very highly reliable, because they have a vast network of servers and they ensure that our application does not fail. So there are some advantages of public cloud. Let's talk about private cloud. Now, private cloud consists of compute resources used extensively by one business or one organization. Now, this private cloud can be physically located at our organization's on-site data center, or it can be hosted by a third-party service provider. Whichever the case, the private cloud services and infrastructure are always maintained on a private network, and they're maintained on hardware and software that are dedicated solely for one organization or solely for your organization. So in short, private cloud in Azure is Azure services being run within an on-premises data center or on-premises data center used by the user to host systems or applications. And some of the advantages is it gives more security. Resources are not shared with others, so a higher level of control and security over our resource and application is possible. And then we have hybrid cloud. Now, hybrid cloud is the best of both worlds. So it combines the features of both public and private cloud. And some of the user components are being run on Azure and others within on-premises data center. So they kind of share the resources. In other words, they kind of share the application. Half of the application would be running in on-premises and half of them would be in the cloud, and they would be working in harmony to support the application and the business need. So that's hybrid cloud. This is another good example question that wants to test how well you pick services, or how well have you understood Azure products and services and are picking the right service for the need. So the question would go like this: what kind of storage is best suited to handle unstructured data? There are a lot of storage options available, and the requirement here is what or which one would you choose for unstructured data? The answer for that question is blob storage, because blob storage is designed to support unstructured data. It works in this way: it places the data into different tiers based on how often they are accessed. Different tier means different performance. Different performance means different cost associated with it. So a lot of add-on advantages will we get when we use blob storage for unstructured data. In addition to it, any type of unstructured data can be stored in blob storage. This is not true with a couple of other storage options that we have in Azure. Only with blob storage we can store any type of unstructured data. And the data integrity is maintained every time an object is changed in the blob storage. And the best part is the blob storage helps increase applications performance and reduces the bandwidth consumption for that application. So they are the benefits that we get for blob storage, and blob storage are the ones that are well suited for unstructured data, and that's what your answer should be. It's really an 5-step process, and if you have done some labs, some basic labs with Azure, you can easily answer this question. So it's a 5-step process. First step is to log into the Azure. The second one is to create an resource or a resource manager. And within the resource manager, you would be selecting the resource. and then pick the operating system. Do you want Windows or Linux? And within Windows, what's the flavor you want? Or within Linux, what's the flavor you want? So decide on it. And then entering the relevant information like the name of the instance or the VM that we're going to launch, and the password, the URL that goes with it, and a couple of other relevant information that gets itself attached with the VM. And then select the size of the virtual machine, different size, different types available for the kind of application and for the intensity of the application that will be running on top of it. So select the size of the virtual machine, review everything, whether they're good or not. If there are any changes required, go back and edit them, and then come back and launch, and your VM is there for you to start working within like 3 or 4 minutes, not even 5 minutes. Within 3 or 4 minutes, it gets ready and you can start working on it. So it's a quick and it's a 5-step process, and you should be able to answer it easily if you have done a few labs in Azure. Let's now look at some scenario-based question. You've been posed with a scenario. So we thought through it and we picked some common scenario-based questions that are being asked in an interview, and I thought we'll present it for you with the answers, with explanation, so you can get benefited through it. So let's look at this question. You're asked to make sure your virtual machines are able to communicate securely with each other to ensure security, or to have good amount of security. What would you do? And the correct and the best answer for this would be using virtual network in Azure, which enables us to communicate with the internet securely, which enables us to communicate with the on-premises data center in a secure fashion. So the advantage of using virtual network is users can create their own private network, users can pick their own private IP ranges, users can create their own subnet, users can create their own routing between those two subnets. A lot more goes into that virtual network, so it's very customizable, and the users are provided with an isolated and highly secure environment for applications. It's completely isolated from other customers, it's completely isolated from other applications that are running in other virtual network that we own. So within our account, we can have multiple virtual networks, and one application running on a virtual machine is completely isolated from other applications running on other virtual machines. And of course, all traffic stays within the Azure network, Azure virtual machine, or within the Azure network, depending on how you set up the routing. If you have set up a routing to go or reach the internet, it's going to go, otherwise it's going to stay within Azure. If you have set up routing to reach on premises, then it's going to go and reach on premises, otherwise it's not going to go and reach on premises, it's going to stay within the Azure. And it also allows users to design their own network, like we already discussed, picking up IPs, picking routing, picking subnets, how many servers should be present in that particular subnet, or how many servers should that subnet accommodate, the size of the subnet, the IP ranges, the NATing, the masking of IPs, creating of VPN, all that's possible with the virtual network. So it really allows users to design their own network, and using virtual machine is how we secure applications in the cloud. Let's look at this other scenario. How do you ensure that every time a user logs in, they are not asked to re-enter the password as part of authentication? So you really don't want your users to re-enter the password every time they log in to a different application. Well, all the applications have their authentication mechanism in place. All of them wants to authenticate the user before they log in. Ensuring the user does not log in every time does not mean that wiping away all the authentication and authorization that's present in that application. You still need that in place, but how do you make the user hassle-free so they're not asked to re-enter the password or the same password again and again? Let's look at the options available. The first one is to enable Microsoft account authentication. Well, it's not going to fix, because with that the user will still need to re-enter the username and password. Deploy ExpressRoute. It's not going to fix either, because ExpressRoute is a network level service that connects on premises to the cloud. So that has got nothing to do with prompting or not prompting for password. And then we have set up VPN between on-premises data center and Azure, set up AD domain controller in VM, and implement integrated Windows authentication. Well,
you can use the same username and password for on-premises and the cloud, but this setup, the VPN and the AD controller setup, it's not going to stop you asking for repeated passwords. So this is all about using the same password in on-premises and in the cloud, and this has got nothing to do with not prompting the user to re-enter the password. Alright, so that's same password is different from not prompting the user to re-enter the password. They are two different scenarios, so that is also out of the equation. And the last one is configure AD sync to use single sign-on. That's the right one. So when we configure the AD to use single sign-on, then it's not going to ask for the username and password every time we access an application, because we have logged in, and that login is going to stay active for like 24 hours or so, depending on how you configure it. And within that time, you can access a lot of other applications, and it's not going to ask for the username and password because you already have a single signed on and you have signed in using the right credentials. Let's look at this one. You need to ensure that virtual machines remain available while migrating to Azure. What would be the appropriate service to use? Right, let's look at the options. Traffic Manager. Traffic Manager is literally an DNS service. And then let's look at the other one, update domains. It again has to do with Traffic Manager, updating the URL. So the Traffic Manager gets updated and then starts sending requests to that particular URL. It's going to take some downtime because when we update the URL, they will have to be populated to all different places, and it takes time. So within that time, any user trying to access, it's going to fail. And then we have ExpressRoute and cloud services. ExpressRoute could be in fact, it's the right answer because ExpressRoute, it's an extension of our on-premises and cloud environment. And in this question, it really comes out from a customer who's having an hybrid environment. So they have applications running in on-premises, they have applications running in the cloud, and they want to have a way to migrate applications from on-premises to the cloud. In other words, kind of do a cutover between on-premises and the cloud. And this ExpressRoute is a service that connects between on-premises and the cloud. So when you do the cutover, the traffic is now sent to the cloud instead of being handled in on-premises. In fact, the services and the application is getting shut down in on-premises. So the request will come in the same pattern. Instead of they being handled in on-premises, they are now routed to the cloud using ExpressRoute, and the API calls get addressed or the queries gets answered in the cloud through the ExpressRoute service. Look at this question. You are an administrator for a website called WebGame, and you are required to validate and deploy changes made to your website by your development team with minimum downtime. So the real question is, how do you validate the deployment changes that's made by the development team? Let's look at the options. Create a new linked resource, create a staging environment for the site, enable remote debugging on the website, and then create a new website. Well, why would you want to create a new website? Just to validate the changes. And doing a remote debugging is not going to help because debugging only captures logs of the changes happening. It does not do anything with validating the changes. Create a staging environment could be or is the right answer, because when we have staging environments, anything that we run on production can be run on staging environment, and any failures that would happen in production, if we simply run it in production, can be captured when we run the application in the staging environment. So that way, staging environment is a very helpful and useful service, and that way I can catch any errors. In other words, I can validate the changes that were done by my development team before I move it to production, and that reduces the downtime in the production environment. Look at this one last question that we have for you. It's a standard tier application is used across the world and uses Azure Website Standard Tier. It uses large amount of image files, so you can get it. This could be an e-commerce website which has a lot of pictures in it. And this is causing the application to load slow. How can we handle this situation? Let's look at the options given. Configure blob storage with custom domain. Well, this application has pictures, but only the pictures is not all that the application has. Right? So configuring blob storage might not help. This could be an very interactive website, and that can't be run from blob storage. Let's look at the other options. Configure Azure website auto-scaling to increase instances at high loads. Now, it's the picture that's causing issues for the website. It's not the CPU or it's not the memory unavailable, memory not enough, that's causing the application to be slow. So we need to identify what's causing the application to be slow. So it's not the CPU, it's not the memory. So configure Azure for auto scaling is not going to help. And then what are the other options? Let's see. Configure Azure CDN to cache all responses from the application's web endpoint. CDN could be the right answer, but look at that. It says CDN to cache all responses from the application's web endpoint. CDN is not designed for that. Though it can do it, that's not the best way to use CDN to capture all responses from the application's web endpoint. The proper design for CDN would be to cache the frequently used ones. In other words, cache the static content, which are photos, videos, logos, and pictures, and a lot more. Static content that never changes. Let's look at the last option. Configure Azure CDN to cache site images and content stored in Azure blob storage. Absolutely correct. So here we will have to redesign the application to store the pictures, high quality, lazy loading or slow loading pictures, because of the high quality and the bigger size. So store them in CDN, and then the content, let it be stored in Azure blob storage. That's the right way of designing the application, and if we do it, this application is going to run faster, or the application is going to respond faster to the users.
And with that, we have come to an end of this video on cloud computing interview questions. I hope it was informative and interesting. If you have any questions related to the topics discussed in this video, or any queries related to AWS and Azure, then please feel free to ask in the comment section below. Our team of experts will be happy to solve all your queries. Thank you for watching, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.